Hello, check. Good afternoon, everyone. I'm Chirag with the Super Fab Lab, and I'll be your MC throughout the evening and afternoon today. First afternoon talk, we have Mr. Quinton Bolse, sorry. Quinton works with the Center for Bits and Atoms at MIT, Massachusetts Institute of Technology in the US, whereby he is also collaborating with some of our teammates from the Super Lab, where we're trying to build machines that make and also a Fab in a Box project. So along with that, Quinton here will cover the evolution of rapid machine prototyping research from the MIT Center for Bits and Atoms. And from early open hardware designs to the current state of modular machine kits. So he'll focus on ease of fabrication across the Fab Lab network, and ultimately he hopes to enable addressing local challenges through collaborative and flexible design patterns. So over to you, Quinton.
Thank you. Thanks for the introduction. That was a lot of big words, but don't worry, we will unpack all of that in due time. So I work with the MIT Center for Bits and Atoms as what? I work at MIT CBA, so for Niels Lab, as a postdoc, but I previously did my PhD in Belgium. So my original research was about removing noise in 3D scans using deep learning. So on the left, you can see the 3D scan, and on the right, the processed result. But that was all code, and I wanted to use my hands. So I found a deal, which is to take Fab Academy. I found a local Fab Lab in Brussels where I could take Fab Academy, and I managed to, incorporate it as part of my PhD, and that was a lot of fun because as an electrical engineer, I was always super frustrated to never actually do my own circuits. So in Fab Academy, this might sound surprising, but this was the first time I actually soldered the resistors we always talk about in electrical engineering. As an instructor, because I took Fab Academy in 2020 and then moved on to become an instructor, I am trying to make fun little projects that illustrate the interesting capabilities of the chips we use. So for instance, you can see here that this tiny chip, the SAMD 11C14, has USB capabilities. It can also do amazing capacitive sensing. And I'm able to compute the 3D position of the finger just based on those 3 readings. Then I also got curious with machine design, because as part of our academy, there's the very scary machine week where students have to build a machine in only 1 week. In my case, in 2020, we were only 2 students, so I had to design at least half of the machine, and I learned a lot doing that. Now, with my current research, I'm trying to simplify the design of machines so that we can distribute them across the Fab Lab network much more easily. So you see on the right, for instance, upper right, this is a machine that's completely 3D printed. Every part in gray was printed with a simple Prusa 3D printer. And on the left, you see a 2D motion stage based on the same principle. By the way, the string there is a very cheap way to make to transmit the motion. It's called a capstan. Okay, so that's some of my background. I also like to hack existing machines or make them do unexpected things. So during Fab Academy, I had fun with a completely normal CNC milling machine, but then I turned it into a sand drawing machine. And by connecting a camera and sort of getting both of them to interact, I was able to make fun stop motion animation like you see on the left. I also built a light painting machine. So the idea is just you have a 3D motion system, and there's an LED mounted on the tool head, and that lets you do 3D line painting. So this is the long exposure photograph of what you just saw. We have time. We can look at the whole thing. There was also a Blender script to design the patterns. And so whenever I'm hacking a machine or designing a brand new machine, I have to think about how I'm gonna control this machine. Yeah, again, this is the long exposure photograph. And the answer is it's extremely frustrating right now, because most of the time you're gonna be hacking a 3D printer motherboard, and you're gonna, modify the source code or find a hacky way to let it behave the way you want. Just 10 days ago, I was working on this project. So again, I had to build a machine from scratch for that one. The idea is extremely simple. You have a turntable, and you shoot a video of an object, then you do something unexpected, I'll show you. But basically, this whole turntable was made in 1 or 2 days. Well, the table itself was plasma cut, but the more interesting part is in the bottom there, you see a stepper motor that's just a USB cable. So Type-C USB cable, the yellow cable you see there, it goes into your computer, and you can power and control the motor. Now, this specific project was about revealing a hidden nature of objects if you get them turning. So I was shooting a video of an object rotating and accumulating the pixels, which is what I'm doing on the right here. And you get something very strange. It looks completely made up, but it's made from actual pixels from an actual photograph. So you have realistic shadows, lens blur, anything you want. And then once you've made one of them, you can also choose to move the line, and you get this insane animation. Okay, one last little project. I'm from Brussels, and you may have heard of the mannequin piece. It's our this little man that's peeing, and it's the most famous thing to see in Belgium, at least in Brussels. You just have to go and see mannequin piss. Mannequin means little man. Piss means, you guessed it. Now, it's really funny because my friend Nicholas, who was my Fabric Academy instructor, someday he contacts me and says, Quentin, they're making a math-themed costume from the mannequin piece, and you have to help us because they want to demonstrate Pythagoras' theorem using a liquid somehow. It's part of the costume, and you have to help us. And so we did just that. I'll play the video. I think you'll get it. So focus on the triangle. It's motorized, and as the liquid fills up, you're proving Pythagoras' theorem. There it is, right there. There. That's the proof. Okay. So machines are clearly very fun, but there's an immense frustration when you're building machines because there's no adequate way to sort of, dice up the problem, share it across multiple people, or even to yourself in the future. It's hard to reuse stuff you've made in the past. So there's a whole branch of research at CBA that was there since the very beginning, because, when we started the Fab Lab network, we also thought about what sort of machines we would find in those Fab Labs. And so we were very concerned initially with how to make machines that are easy to spread, easy to assemble, but also easy to understand and replicate. Of course, I wasn't there back then, so 90% of what I'm about to show is other people's work, which makes it a lot easier for me. So about 10 years ago, there was Nadia Peak and Jonathan, you see there. And one of the first machines they built is the MTM Snap. By the way, MTM stands for Machines That Make. And that was a very smart design because you can simply mill it out of a thick HDP plastic sheet. And you can't get it wrong when you build it because there's a very subtle assembly method there. You see, I'm not sure you can see it, but on the sides, there are 3 fingers that self-align when you snap the machine together. And so no matter how sloppy you are when inserting the panel, it will self-register and ensure that the machine is perfectly 90 degrees everywhere. So Nadia's research was always about, cheap machines, but high precision when you assemble them. And so the next project was this one, FAB. It's a general purpose machine, so it can do multiple things. It's not even just one machine, but it's more like 3 or 4 machines. And it fits in a suitcase. So you can open it up, and I'll show you the video, it's easier, but basically once you prop it up, you can assemble a tool head. There's a very precise mechanism to align tool heads. It's thanks to these 3 beads you see there at the bottom right. This is called a kinematic mount. And because it's metal on metal contact, it's isostatic. It ensures that the tool is always exactly at the same spot up to the micron level. So let's take a minute to watch this video. If you've ever moved a machine, you know how frustrating it can be to recalibrate it, but here it wasn't an issue thanks to that little trick. Okay, so now we have machines, but what about machine elements? This is her next project, and Ilan Moyer was part of that one project. I'm sure you know Ilan indirectly because he then later on started a spin-off called Shaper. So if you use the Shaper, handheld CNC machine, it's from Ilan. So those are modular axes. You can assemble them to very quickly prototype a machine architecture. And there was also this experimental modular electronics. It was called Gestalt nodes. So the idea is you're just daisy chaining those modules, and each of them is controlling one motor, and together they form a cohesive machine system. Using a computer, you can choose how the machine behaves. And that's a research track that is still ongoing today. Here's a very quick video of them making a machine from scratch. This is the hallway at the Media Lab at MIT. If you've ever looked closely at a Cartesian 3D printer, then you know that the motion can be separated in each axis, and this is what we do here. So that specific machine was a hot wire foam cutter. Okay. Now, that axis was quite hard to make and spread, so she decided to try to do it out of cardboard. This piece of cardboard can be, laser cut or even just using a knife cutter. So this is extremely easy to replicate. And although, cardboard itself is very bendable, the way she folded it made it quite sturdy, surprisingly sturdy. At the time, they also envisioned this whole ecosystem of, configurations and modules. So you see a linear axis module, but there's also a rotary axis that would let you make a machine that moves and spins when needed. Okay. After that, shortly after that, Nadia left, and she's now a very successful professor at University of Washington. And the current Nadia is Jake. Jake is a good friend of mine, and he's still making those modular machines with, tool changers. His main machine line is called the Clank, and you see 3 different versions of the Clank. It's still evolving to this day. It's a bit hard to track. But the main idea is you get a motion platform and you get to design your own end effector. And again, as before, it's a kinematic mount. So the position of the tool head is always very accurate every time you change it. Here is an example of tool heads you might want to put on that machine. And again, because the positioning is extremely accurate, you can think about automating that change. The machine could simply, park in a specific location and choose its tool head on its own. And upon latching the mechanism, the positioning would be always very accurate. Then more recently, Neil was exploring how to make a modular machine that's as simple as it gets when it comes to the electronics. And I was lucky enough to help a little bit on that project. So you see here a stepper motor that is simply fed 1 USB cable. That's it. Each motor is just 1 USB cable that goes to your computer, and that's enough to provide it with current and instructions. Now, the instructions were outrageously simple. It was just 1 byte that tells you move 1 step to the left or move 1 step to the right. That's it. And each motor gets those bytes individually because they have their own USB cable. Together, you make a machine that doesn't even know it's a machine. It's just receiving those bytes at a given rate, and that makes it move at a given speed. On the left, you see the 3D printed axis I showed earlier, and here it's accelerating back and forth. But the way it's accelerating is not something that's in the machine. It's the computer that tells it to, to go at that speed by sending the bytes more or less faster. And again, the PCB for controlling those motors is extremely simple. You can make it in a fab lab. Okay, so now I'm gonna try to make some points about why we're struggling to do modular hardware, but modular software is really simple in comparison. What's the big difference? Well, the first thing is software encourages you to document as you go. If you've ever, worked on a piece of code several years later, you know how precious comments are. Even the most obscure, incomprehensible piece of function would probably have 1 or 2 comments. So this is one of the funniest functions I know of. It was part of Quake 3. And we still don't really know how it works, but it was able to compute an inverse square root very fast. And this was used for the lighting. So the programmer didn't really know what was going on there, but he still left a very friendly comment. I think the second reason is that code is modular by nature. It's actually much harder to make code that's not modular than the opposite. Whether you're doing functional programming or object-oriented, you're always somehow slicing up your code in linear functions because you want to reuse them later on. And once you've done that, you might as well just share it with other people. And lastly, I think the third reason it's so successful at sharing and collaborating is because the tools were there since the beginning. It's very easy to work together on a piece of code using Git, for instance. It was there since, the start of Linux. Now, for hardware, we haven't seen the same revolution. It seems everyone is designing their own machine, but we don't think so much about modularizing the pieces of the machine and reusing them later on. And there are several reasons for that. So here on the left, you can see a typical 3D printer motherboard. And on the right, this happens to be a CNC milling machine motherboard, but in both cases, you have a single motherboard for the whole machine. This is quite bad because it means you're always going to be limited to what connectors you have available on that motherboard. So if you want to add one motor to your machine, you might be out of luck because you're out of drivers on the motherboard. But at the same time, it made sense to at least start doing machines this way because, you know, a microcontroller is kind of a big deal. At least it was 20 years ago. So if you're going to place one, you might want that single microcontroller to control the whole machine at once. And you also have a single piece of code to work on to control the whole machine. But nowadays, it's become a frustration, at least for me, because let's say I want to add one motor to an existing machine. What do I need to do? Well, if I'm lucky, there's going to be a spot on the motherboard, and I can just go and connect the motor. But that's not enough. I have to go in the source code and declare this extra motor. Then I have to recompile this whole source code, flash it to the machine, perhaps even reconfigure the machine because it's lost its configuration in the process. And then, you know, the machine has this extra motor, but you also need to tell it to move now. So if you're lucky, G-code will include this use case, but it might not be the case. And you might be, you know, having to write your own hacky G-code command just to handle this extra feature you've introduced. So, yeah. After that, you still have to tell the machine to use this extra functionality. And so even the host computer is involved in the process. There has been some progress in the Maker community regarding all of that. I think the Clipper firmware and ecosystem is very promising because it lets you use a single Raspberry Pi and several attachments. And it's quite modular. You can just add them on the fly using a bus. So in this case, it's the SPI bus. I'm pretty sure they also support I2C and others. But as far as I know, you still have to pre-configure all of that. You have to declare that, you know, you've just added a module. There's no concept of discoverability when you connect those new modules. So we thought about that at CBA, and last fall, when we were teaching how to make, which is the MIT version of Fab Academy, or it's the other way around because it existed for 20 years now. We wanted to make the students' life easier during machine week. So we thought, okay, what if we finally did modular machine parts? The students get those individual parts and they can assemble them together to make a cohesive machine. So because we're really bad with names, we named it modular things because it's modular and, you know, it's a bunch of things. I'm not going to play this whole video, but this is just the presentation we made for the paper. The main idea is this. You connect them to the computer using a USB cable and they show up. And when they show up, they tell you which functions you can call. That's as simple as it gets. So you get this little JavaScript editor on the left, and in only a few lines of code, Jake here connected the potentiometer to the server. That's all it takes. Because it's in a web browser, this also lets you create your own UIs. Let's see what that might look like. Yeah. So this was a fun little music machine that we made. And, well, the JavaScript code for that is on the left, but we also made a UI directly in the browser to compose a given music partition and play it. And here you can see some of the machines that the MIT students built during Machine Week. There was a pancake machine, a sand drawing machine, I think. And yeah, we loved the pancake machine. Okay. Okay, so that was the past and present. Now I want to think a little bit about the future. I think there's a few recipes that we should keep in mind to make sure that we can share our pieces of hardware that we're developing. Okay, the first one I think is to embrace that we should decentralize the electronics of the machine. It's perfectly natural that, you know, a different person is going to work on the extruder or on this stepper motor here or on the heat bed. We should have individual PCBs for each of them. This is the way to make sure we can slice it up and make it manageable, even in case of very complex machine with maybe 30 of these. The second is something I still haven't seen. It's discoverability and self-documentation. When you plug in a new piece of hardware in your computer, you shouldn't have to read a manual. It should tell you what it can do directly. So my dream is to have a nice little protocol that would be completely universal and that would let us declare and trigger APIs on the fly. So if I give you my stepper motor, there should be no mystery in how it functions. You should be able to plug it into your computer and it will tell you, okay, I know this function. You can move me by, you know, some amount of steps at a given speed. And you can even have a cute little documentation that comes with the function, because now the flash storage that we have in microcontrollers has become, you know, reasonably large. So we could store these descriptors, but also a small little documentation that, you know, probably in English, a few lines that describe what the thing can do. I've been thinking about this language thing a little bit. It's kind of annoying to think that this descriptor would be in English, but we program in English anyway. So I'm not sure about that one. It might be that the name of the functions should remain in English, but then the text that comes with the function to describe what it does could be, you know, translated to the region you're in. That's not too important. Okay, the next recipe is to think about object-oriented hardware a little bit. Because now that we have those nice little descriptors, we can think about classes. A generic extruder would probably have something like set temperature, or extrude, or tell me the diameter of the nozzle. But then you can specialize this class. You can have children classes, like a clay extruder would have extra functionality. A multicolor extruder would have different extra functionality. But as a community, we agree on the base functions that an extruder would have. Then we can start thinking about those recipes and share them. And I think it's significant. If we can just agree on what those classes should be, we don't even have to materialize it. We just have to think. And we can share those recipes together and build this sort of tree of modular machine components. Next, once you have all of that, you can think about software-defined machines, where the behavior of the machine is not at all in the end nodes, but it's in the computer. When I say computer, it might be, you know, a chunkier microcontroller. That's also fine. But basically, the end nodes of the machine, so here, in this case, you have a stepper, a server, and a button. Each of them has no idea it's part of a machine, but it can transmit messages using the protocol I described before. And, you know, just by triggering those function calls, you can build a cohesive machine. The main concept here is to keep as much of the state as possible in the host, because then the end nodes don't have to worry about the current state of the whole machine. They only know about themselves. But then the host can decide that, you know, the machine needs to be homed, or it needs to move at that speed at this moment for whatever reason. And here's a little demo I did about 1 year ago that shows how simple life could be if we had this this high-level software-defined machine system. So here, I connected a potentiometer to my computer, and it shows up and gives me a single output value called level, and I get to connect it to this machine, for instance, and now they're tied together. And remember, if we had this great little protocol I described earlier, this would come at no extra cost. the hard work would be done already, because we would agree on what the bytes should be between those two pieces of machines. Then the computer would simply be piping those bytes to the correct end nodes. Okay, finally, I want to kill off G-code. So how might we do that? I think the idea is to allow parametric path instead of just line segments. I know that G-code also supports arcs, but no one really does it, except in the CNC milling community. Sometimes you would have line and arcs. That's great. I also want to have Bezier splines if possible. And once we have that, we might as well think about how fast the machine should go at each of these points along the Bezier curves. And this is a little experiment I did last spring, because Neil teaches a math class at MIT, and this was my project for the math class. I have this Bezier spline, and I computed how fast I'm allowed to go, given all sorts of dynamic constraints. So one of them is how much the acceleration is limited on this machine. Another one is how fast you're allowed to go max. So, you know, if you saturate your speed, probably don't want to go any faster than that. And those constraints become horribly complex at some point, because your current speed affects the future, but it's also defined by the past. So it turns out to be a quite complex diffusion problem. But I'm excited by that, because I think this lets us push machines to their limits. If you think about 3D printers right now, they always move at a constant acceleration boundary. And we always keep this acceleration well within the torque limits that the machine can achieve. But that means we still have this huge budget of acceleration that we don't dare to use, because we might stall the machine. This budget is complex and depends on your current speeds or the direction you're going in. But if we could get closer to this theoretical boundary, then machines would effectively be faster. So that's one thing. Also, we should have as many degrees of freedom as we want. We should be able to give them arbitrary names. So if you're making a machine with a rotary axis, there would probably be a theta, you know, an angle parameter. And this G-code version should allow for that. And then real-time conversation with the machine. That's the idea that some of the machine's behavior is highly complex and depends on external parameters or even user input. So for that, we should be able to have a high frequency closed loop communication with the host computer. Right now, if you've used a 3D printer, you know how much G-code is decoupled between your host computer and the machine that runs it, because you just send those commands and forget about it. If you're lucky, it will tell you which line of G-code has been executed, but that's about as, you know, fine-grained as it gets. It would be great to agree on the actual instantaneous position and velocity of the machine. Okay, well, this is almost the end of my talk. I just want to introduce this future project of mine that is Fab in a Box. It's been around for a few years, but I want to start from scratch and really think about how we can integrate all of the concepts I've mentioned before and make a modular machine kit. So you would have this single unit that's just an axis, and you get to compose them together. Notice how there's a connector on each face that would let you connect them mechanically, but also electronically. And it could sense that you've connected it this way, such that at least the host computer could know what the full machine looks like at this moment, the way you have composed your axis. And so there's still a lot of challenges to get there, and I think one of them is to develop the protocol I mentioned, because if we had this protocol, then we could simply agree that each axis, takes function calls and moves accordingly. Also, notice how it would be trivial to add an end effector to this machine, because it's always the same meeting system. So you could connect another axis or simply another tool head. Okay, that's it for me. Don't hesitate to reach out. I love to work with other machine builders, so that we can find, a solution that makes everyone happy. Thank you.
Yeah, Quentin, the AV department has a question.
Sure.
Yeah, actually two. So in Rumble, you were using one USB cable for each motor, right?
Correct.
So that is to avoid collision. Like the way I think about Rumble would be more useful is if you had a single line, like a serial connection, and then you could just keep adding and adding motors, because this has a limitation of the number of motors you can plug. So why is not this a serial connection is one like 1-to-1? Is any reason for that?
So when you mean 1-to-1, do you mean like a daisy chain?
Yeah. Like a daisy chain, yeah.
That's a good idea. But the problem is, there are two problems. The first one is you're going to get a significant latency if you want to send the messages to the furthest node. Now, if you have, around 10 nodes, it's not a big deal. But the main problem, the main difficulty is that between those nodes, you would have this USB cable that would require to have a host in a device every time. So each of the nodes would be significantly more complex because it would sometimes act as a host, as a USB host. Now, of course, it might be smarter to use a serial cable instead between them. Sure. We've done that. Actually, we're working on that. NIDA has just developed a protocol for that called broad hop. So it's a broadcast. It's kind of finicky. There's a broadcast from the host computer to every node so that there's no latency. But for the message to come back, you have to daisy chain. You have to hop across the nodes. I think this is the best of both worlds because most often you care about latency more when you're sending a message to the machine. So there would be no latency in that case.
Yeah, but so if you would do like broadcasting a message, so you have a 3D path, for example, with acceleration and all, and you have to divide this into bits, individual bits, right? So to send one bit to every motor. So wouldn't that be in a situation that 2 bits have to be sent at the same time? They will collide?
I think at that point you need to think about addresses. So you would have a dedicated bit or series of bits to address one of the nodes. Or you could even, agree that a message is 2 bytes long and that the first 2 bits are for this node, the first next 2 bits are for that node. And that's why there's no real collision problem because you're always transmitting to everyone at the same time. Actually, even with a single byte, you already get a lot to play with. Let's say each message is 2 bits, then you can address 4 nodes already with just 1 byte.
Oh. Who can do a runner for me?
Hi, I'm Andre, and my background is in robotics and industrial automation. So I work with industrial robots. And for me, the talk was super, super cool, but also a little bit funny because this is what industry is doing for like 30, 40 years, right? Mm-hmm. They arrive to those predefined communication protocols that are usually coupled with the hardware like Ethercat, Profinet, and all those things. So maybe I have 2 things to say. So maybe it's good to look into that because that already exists for industry, as well as this like block diagram. There's literally a programming language in industry that is called block diagram programming, which looks exactly like that. So maybe it would be good to just unify it, and like use what already exists in industry, but for maker purposes. So that's one thing. And the second thing is, what is annoying about industry is how incredibly non-flexible it is. because once you decide on something, it takes forever to like make any innovation because everyone has to agree on new implementation, new protocol, new ways of communication. You know, so like basically the industrial, like the way how machines are programmed right now in industry is extremely obsolete old way how it was done in 80s. And no one can change that anymore because there's so much like legacy code and legacy stuff that already happened, and you would break the backwards compatibility and everything like that. So aren't you afraid that if you like unify it in this way, it will basically make it prone to be stale and you will like curb the innovation in this field?
Yeah, that's a great question. So first of all, by all means, if this protocol exists, then let's just adopt it in the maker community as well. That would be extremely constructive. But then I think what you mentioned about the standards not being flexible can be solved with one key thing. With software-defined machines, you always get to wrap an obsolete piece of code with a new piece of code. You get to have virtualized translator that that would let you interface with old stuff, outdated stuff. So I think as we move towards a more software-defined description of how the machine should operate, we can solve those backwards compatibility problem with very simple interfacing pieces of code.
Okay, thanks.
Yeah, my name is Peter. I could not understand everything, or partially due to sound quality, but maybe you can explain, possibly again, how to draw a circle. You did it with 2 axes, and I am wondering how these axes, when they are independent, how they can produce a circle of reasonable quality.
Okay, so part of the answer is here. If I give you a curve over time and a speed at which you are supposed to read the curve, then you can effectively draw any shape in n dimensions, because think about your individual axes. So you want to draw a circle in 2D, right? You have an x-axis and a y-axis. As you know, the position over time would be a sine and a cosine, respectively. If I could transmit to those individual axes this function of time, as well as the reading speed, then they could read that trajectory over time. And even though they don't know anything about the other axis, simply because they are reasonably well synchronized in terms of, current time, then the trajectory would happen on its own.
But in that case, you assume that the X machine and the Y machine are exactly the same machines and have the same speed and the same behavior in time. You are not coordinating that. If you set one step, I wait, and then I set my next step.
The reason is we expect those machine components to behave perfectly. Yeah. So they would always be exactly where you want them to be over time, because if it's not the case, it's kind of their fault, and they have to introduce their own closed loop control system to make sure they keep up with the pace.
Yeah. But that is again something from the early days of computing, and never assume anything about the speed of the hardware.
In this case, I think it's a bit different, because we have to agree on what speeds your motor are capable of, right, in the first place. So we have very clear boundaries on what those machine elements can achieve, and we always steer clear of those boundaries.
So in fact, it is feed forward,
not feed forward,
not feedback.
So if you want the feedback, then you should do it at the end node level.
Okay, thank you.
But again, sorry, there is one key thing here. The last item here actually says that if possible, we should also be able to communicate with the machine in real time. So at least the host should be able to know where the machine is exactly, and send, corrections if needed. So if you want to include the host in the closed loop, that should also be possible.
Thank you.
Mhm. Yeah, for sure. Yes.
Is there any reason why you're using USB? Why don't you use just an Ethernet cable and Ethernet stack, which already has addressing? It's faster, it's reliable. You can even feed power through it. It's just simply better.
I don't have a good answer for that, but everyone has a USB port on the computer. So it's just a way to mess around very quickly with those.
Yeah, but like one simple adapter will give you also Ethernet port if you don't have it already in your computer, which...
That's a good point. I guess another reason for us was to implement the PHY layer. You need extra hardware, and we wanted to keep the cost very low at the end node level. So if you look at what we did in practice, we just have those great little shower modules from Seed Studio, thanks to Eric, that already have the USB connector and everything. So it's just $4. It works, and there's no extra hardware. Now, for more serious applications, I completely agree, and it's something that CBA has done before, to use Ethernet cables.
No, but maybe like because you are thinking about it with, like you're trying to build something from ground up in a way. You know what I mean? So maybe, why don't you just use the best possible solution from the beginning? I know the boards exist more with USB ports and everything, but like then maybe this is actually the wrong way how to do it, and it should be just done a bit differently from the beginning. Otherwise, you lock yourself in something that is just simply not ideal for the situation, and then you have to program your whole addressing and all those things, which is actually already solved in the Ethernet stack anyway, so you don't need to deal with that if you use it directly.
That's very fair. But while we talk about stacks, one of the key points here is that they're interchangeable. So if you want to implement the lower layers using Ethernet or USB, that's fine. But the higher level protocol should always be the same, right? At the byte level.
Yeah, absolutely.
So,
I agree with that.
So that's good news, because, in the maker community, if some guy wants to use Ethernet and has a complete solution for that, then we can integrate it, because the higher level will still agree.
Okay, thanks.
Those are great questions. We can talk later.
So I don't know anything about robotics. I come from like the user experience, industrial design side, but you mentioned that you want to like collaborate with, robotics builders. I was just wondering, since this is going into like, going to the consumers, like what are you guys working on like with the user experience, and like, are you guys open to working with industrial designers or
We're looking for
average
some.
people?
So
Okay.
please contact us.
Okay.
We know nothing about the user experience.
All right. Cool.
It's been quite catastrophic so far. So I'd be really excited to have someone think about the front end.
Yeah, because like from my perspective, I look at it from like, what would a person who knows nothing about tech,
Yeah.
how would they interact
But
with
then
this?
I look at Grasshopper or MaxMSP, and I think, well, those are great. You don't even need to learn how to code. You're just connecting nodes. So this, this is ugly, but it does that a little bit. It was just an early experiment. I'd like to have a more coherent node system, because then it's really exciting. You get to not just connect messages from one part of the machine to another, but also transform it or have user inputs from the computer. Anything is possible. And again, if you had the protocol, you probably do, but if you had the protocol to talk between machine components, we might as well have virtual machine components that live in the computer and talk the same protocol.
Thank you.
I was wondering if, as you said, in theory, you would like the part, for example, the stepper motor, to know exactly where he is. So, for example, you don't want to have hand stops. I was thinking in a classical machine, you have for each axis, you have 2 end stops. So it would mean 3 cables for each axis, plus all the things for temperature and anything. So you end up with a machine that needs 15 USB cable. Or do you plan to have for each stepper motor that the stepper motor includes somehow the end stop to know always where he is? And
That's a great point. So in some cases, you can conflate some of the functionalities of the machine, right? So if you introduce one more motor, you might want to introduce its own end stop at the same time. So in that case, we allow for some sort of merging of 2 boards. And actually, as a matter of fact, this board has 1 pin where you can connect the end stop. Okay, I think we're right on time. Any last question? Otherwise, you can always find me and ask. Okay.
Sure. Oh, thank you, everyone. Thank you, Quentin, for this session. And yeah, you guys have been very interactive. Really appreciate it. If you have more questions for Quentin, please feel free to find him around. He'll be here till Friday. So you guys have a lot of time to interact with him. Again, thank you so much. And Quentin and the Super Fab Lab, we're trying to build a machine that can make as well. So hopefully we can work on this for a long time to come. And then hopefully some of the school students out here in Bhutan get access to that machine as well. Thank you, Quentin, for your time. Thank you, everyone. You guys have been very interactive. And for the next event, we have Mr. Georg Dremel, who works with the Fab Lab in Kamakura, Japan. And Fab Lab Kamakura and the Super Fab Lab have been really close in terms of Rico, who also works with Fab Lab Kamakura. He was the instructor with us for the Fab Academy this year. Anyway, I hand over this podium to Georg here. Please give a big round of applause for Mr. Georg. Thank you.
Got it. Okay, we're a bit early. I think 1 minute to go. Please come a bit in the front. It's really super weird to have to shout. Especially the people in the cheap places on the back. Come a bit in the front. Now, today you are VIPs. You can sit at these benches. Or just stay where you are, that's also okay. Okay, then let's start. So, my name is Georg Schreppel. Thank you for the correct pronunciation of my name. I'm very happy. So, I'm from Austria. We speak also German, but I'm based in Japan since many, many years. And today's talk, I would like to talk about the BioClub Tokyo, what we do there in terms of bioart, how we came to do actually BioFab there, and how I came to be part of this amazing community here, and also what it means, how I hope we can show you how to add some more bio already existing fab communities and fab labs. So just a little bit about myself. I don't want to go through detail, but just some keywords, so maybe something resonates with you. So actually, I have a background in media art. I came through biology. Well, not really. I studied a little bit biology, but I don't have a degree in biology. But I've been working with art and science since many years, about 20 years. I also have a degree from the Royal College of Art in interaction design. I was very lucky to be part of a group that worked with Tony Dunn and Fiona Raby, what later became speculative design. And I was always very conscious of not being a scientist, so I had a chance to join the lab for DNA information analysis at the University of Tokyo. So I was actually working 10 years doing cancer genomics and visualization of cancer data, which was a very amazing school, but it also taught me a lot how universities work and that they're basically very silos and it's very hard to do something else there. So we had like 100 labs there, but because I was a bioinformatics guy, I could not join any wet lab and do any experiment there. And that actually led to the establishment of the BioClub Tokyo, which is Tokyo first biohacker space and community. And yeah, and I'm just doing a PhD now. Yeah. So I would just like very briefly introduce you some of my artist projects and then later talk about the BioClub, what we do there, and then at the end about some education opportunities like the BioAcademy and especially the Biohack Academy. So when I talk about bioart, I don't really mean, so I always mean a critical engagement with biology or what it actually is, what we are working for. So it's not, we don't really want to make something beautiful, but we want to ask questions and raise certain issues, right? So this project is called Common Flower, Flower Commons. And this was me at a Bio Japan meeting also many years ago. And this was actually, this is a very special flower. And this is the first genetically modified product which was neither human food nor animal feed. But it was on the market. It is on the market in Japan and the rest of the world, but there was no discussion whatsoever whether we want this or not, right? So they introduced, so the company Santorit, they introduced a gene from a blue, from petunia into carnation, and through many trials and errors, they actually got some blue colors going and the different variations of the blue. But the fact that there was no discussion was very interesting. So I decided to turn this very special flower into a common flower, right? So you get the common mouse, common flower. And this was actually my first biolab. So, and I just would like to show you this, that bio doesn't have to be complicated. It can be very simple, and that's all you needed. And basically it's a clean bench, you just spray it with ethanol, you have the containers, we made the medium, and we got the flowers with the tissue culturing, and they grew, right? So we turned the dying flowers, which are nearly dead, but not quite, into living plants again. And actually what we found, so they grew very nicely. It's hard to see a bit here now, but this is actually a sake cup. It's called one kaposeki. And they actually had some nice scenery pictures of nature and mountains imprinted. And the flowers, they grew very well in that. You know, I think we did not figure it out, yeah. But basically what we could do, we could clone this genetically modified flower, right? We can bring it back to life, we can clone it. And of course, once we had these common flowers, the next step was to release them to the environment and create flower commons, right? But oh my God, in Europe, can you release GMOs to the wild? Well, it's a gray area because the company who made these flowers, they applied for permission and they are allowed to do this. So our question was, are we also allowed to do this? Can we make a private copy of this flower and create it? Yeah. Actually, this was, just to give you a time frame, this was like nearly 15 years ago, so it's not recent, but it got some prizes at Ars Electronica and things like that. Yeah, and this is, I always like to show this shot because we actually established a makeshift biolab in the, I think it was the how is it called? The Wallraf Richards Museum in Cologne, the museum for the 21st century, and the museum, the director of the museum was really worried that our plants would contaminate his Picasso and his paintings, right? And we were more worried that his paintings would contaminate our plants, you know. But this is an example of when you work with bio and art, you always have to make shift labs. You always, whenever you do something, you have to create the environment to do something, right? And this is, yeah. So a follow-up project was, we actually wanted, or still wants, to remove this blue gene, which the company introduced, and ask the question, if we remove this blue gene, can we restore the flower back to its original color? So it was a white flower, the company introduced a blue gene, it became blue. What if we remove this blue gene, can we restore this? And what is actually the legal status of this resulting flower? And actually we tried with mRNA, and this is actually just when CRISPR came out, and I think this was one of the first artworks which actually used CRISPR in an artistic context, you know? So we did many experiments, we could not quite finish it because money ran out. But we're still kind of working on it, and the kind of idea is, yeah, it's still a very valid idea, I think. And this was, yeah, again shown at Ars Electronica, yeah. And this actually leads me to another project, which I did just this year. I'm still doing this year as part of the Bio Academy. If Eyal is here, yay, thank you. So yeah, everybody who made the FAB Academy should also make the Bio Academy. It's really an amazing thing. It's very hard, but you learn so much, you know, and this opening of but the challenge is you need to have your own lab, right? That's the thing. So this is called the non-GABA tomato, and this is actually happening right now in Japan, but also in the EU. So with CRISPR, the legislation concerning genetically modified plants is very challenged, because there's now the notion that CRISPR-modified plants are actually not GMO plants, because you can make very precise cuts, precise edits. And if that means they are not considered GMOs, that means they also don't have to go through the testing and biosafety procedures to go to the market. So because of that, this so-called super tomato or GABA tomato is on the market in Japan. So basically, they found out that by disturbing certain pathways, the tomato produces a higher GABA content, and it's kind of it became a health food, right? Which is kind of interesting. But I want to apply basically a similar approach as if the white out and common flowers. I want to know which part was deleted, and I want to reintroduce the missing DNA part. And again, restore this tomato to its original or natural state, whatever this is. But here, again, we have the same legal question. Once we do this, okay, yes, these are some pictures of my little garden. They're growing very nicely. Yes, and they have a very nice illustration of how it's done. Yeah. So once we reintroduce the missing DNA sequences and we create a genetically identical plant to the original plant, it will still have the status of GMO because we actually edit DNA, right? So removing DNA doesn't constitute the GMO, but adding one does it, you know? So it's very confusing, I would say. But I think this is also quite interesting because also the legislation, also the countries around the world are not sure how to deal with this emerging new life. Right? So the US, Europe, Japan, they all have different regulations of how this is done. Yeah? And I got so far, I got the primers. We still need to, next step is to do Sanger sequencing, which is going to be quite exciting to actually get the data out. But it takes, working in a DIY lab takes a little bit longer than usual. And yeah, so again, the bioacademy system, you had local DAs like Eyal, and there were also a great cohort of global DAs, and especially like Henry, Aditya, Austin, and Elaine, right? So maybe some of you know Elaine, Fabla Bali. Yeah, okay. Yeah. Okay, sorry, where am I now? I'm lost. Yeah, okay, so this is still the Gabber tomato. So yeah, we use the bento lab to do this, and it's still a work in progress. So we still need to make the plasmid and get it done. But just the fact that we know now how to make the plasmid, how to construct the primers, how to get it done, where to get it, what to do, is actually quite a very, very huge step, right? So, okay, very quickly about this. I'm also very curious about the history of genetic modification and what does it actually mean to modify life. So maybe you know, maybe you don't know, but the IAEA, who's actually concerned with anything that deals with atomic power or atomic energy, has also a very large biotech section. Why does IAEA, why do the atomic people care about biotech? And the reason is because in the 60s, before genetic engineering, the way to get new varieties of plants was done through mutation breeding. So basically, you had a mutation source, you had your plants, you bombard them with radiation, and if you're lucky, you get a mutation. Of course, there's no control, but most of our plants you buy in the supermarket are actually done with this way, right? But this is an example of kind of natural modification because we don't control, and of course any type of mutation can also occur spontaneously. So, but why this is interesting? Because I found in Japan there's still an existing so-called gamma garden. This is a little zoom in from the Google. And what they did like flowers, which is very easy. And actually I managed to get a visit there some years back. And that's how it looks like from the inside. So you got some earth walls, you got the gamma source, each day from 9 to 5 they radiate, and you got some plants around it. Yeah, and that's very happy with a Geiger counter, maybe a bit too happy. Yeah. And actually what I'm trying to do, I'm trying to make a miniature model of this gamma garden called the alpha, beta, gamma, the delta garden, you know, the difference. And while I did research for that, I found this amazing open science, not open science, but science hardware, or like an ancestor of DIY bio. And this was from the early 70s, and this is the Gamato 50. So radiation for the home biolab. So basically what they did, again, it's a radiation, it's a gamma source, this is basically all shielding, and you could put your sample, your seeds or your plants here, you radiate it, and then they will mutate, you know. And this is really, really amazing. And Philip from Bento, he's a very good friend of mine, and actually we're trying to make this happen. So, but the funny thing is that I think it was a program from the US government, that was supported by the US government, but in the 90s, they actually lost track of these radiation devices. So they were in the basements of schools and universities, and there were active gamma sources there, you know, so they had to issue really a recall to get them back, and this was a bit of a, because they could also be made for dirty bombs and stuff like this. So it's kind of interesting how bio and atomic energy always kind of merge. Yeah, so we're trying, okay, because I'm from Vienna and the IEA is also based in Vienna, and actually trying to make this garden inside of the Vienna. And this I just want to show for historic reasons, because that's the reason why I started actually being interested in art and bio. So when I was still a student at the RCA, we started this project called Biopresence, and this was very much informed by the kind of completion of the Human Genome Project. And we were challenged by Donald and Fiona Raby to think about possible futures that we as artists and designers can do with these biotechnologies. And what we proposed by then, like 20 years ago, was to store human DNA, or to create human DNA trees as living memorials, right? So we found a method, we collaborated with Joe Davis to store human DNA data in a binary pattern, and this binary pattern is then encoded within DNA of a living tree. So the way the method works, the genes of the tree will not change, but the human DNA data will be stored there. So of course, we're very interested in the technology, but we're actually more interested in the social consequences if this will really happen, because when you encode your DNA or the DNA of your relative into a tree, what does it mean to the tree and your relation to the tree? Yeah, suddenly you become kin. Yeah, you become family, and how would you treat this tree then? Yeah. And this actually, I show this project because this was my motivation to get into bio, to learn bio, to know more about it, to learn how to modify it, and all things like that. But of course, this was 2001, so there was no CRISPR, there was DNA synthesis was very, very expensive, the legal status was very, very unclear. But in the last 20 years, many, many things changed, and actually we are actively working again to make this happen. And yeah, so we kind of always make the joke, so if you put Mrs. Smith's DNA into an apple tree, would you eat an apple from the Granny Smith tree? Yeah. Yeah, it takes a bit. And actually, we got some, I had a biotech company in the UK many years ago, so we got some funding from Nesta. We kind of tried to create it, but of course it was way too early, so the technology was still was not there. But it was an interesting experience to get this done. Yeah, so yeah, things changed a lot since nearly 20 years, and we are really looking forward to make this happen. And we're still getting messages from people who say, okay, I promise you not to die before you can put my DNA into a tree. So this actually creates a lot of pressure to finish this project. Huh? So, but this was my story, how I actually ended up here and how I created a biospace, and then I finally joined the FAB community, and that's why I'm here. So, because when you make art projects, yeah, you always ask to also make a workshop, right? So you always, because you know the museums always want to have something extra. So we made many workshops, and at some point we had a chance actually to get a space in the middle of Tokyo in Shibuya, co-located with the FAB Café Tokyo, and it's a very small lab, so it's actually very difficult to get a picture of the lab. I looked very hard, I couldn't find one. But this is the lab. It's about 20 square meter. We do have a clean bench. We do have incubators. We do have PCR. We do have nanodrop and nanopore and things like this. So it is a small space, and it's actually biosafety level 1, right? It's not just a hacker space. It's a proper biolab. We can do genetic engineering. Of course, we follow all the rules. But this is the place we started. And because we are hosted by FAB Café, we do not have to worry about rent, so which is a very good thing. So therefore, we can also offer access to the space basically for free, but we have the stipulation that everything that happens in the lab needs to be documented and shared. So it's not possible for people to come to the lab and work on a secret project. Everything that's done there has to be open. And this leads me to a little excursion to open source hardware. I just want to highlight some of my friends, and again, they're responsible. I came to FAB actually. So a big shout out to Hakteria and Mark Dusele, who started this kind of whole traveling movement, I think 2008 or even earlier. And of course we have Urs Gaudens, who's like this amazing Swiss hacker who's also a bioacademy, one of the first bioacademy alumni. And he's this amazing engineer, and they challenged to make open source hardware, and this was 2015, right? So the question was, can we make open source hardware in a very cheap way so it can be used by more people? And that's how it looked then. And actually, that's how it looks now. So this is the Pocket PCR. Please come and find me later. I got one here, so you can look at it. And this costs 99 euro. I think actually it was cheaper last year, but he put the price a bit up. But this is basically just a PCB board with a heater. I think it's a SAMD, a screen, and that's it, right? It's open source. You could make your own if you want. But I think it's also great to support the makers so they can make more. And for those of you who know PCR, it's a very simple PCR. It doesn't have a top heater, so you need to use mineral oil to run it, but it works perfectly, you know. So it works the same as any other more expensive PCR machine. And yeah, so this is Urs. We had a nice workshop with him in Vienna. And Urs, he makes so many other things. So he also made the open drop. It's basically a micro, it's microfluidics, but it's electrowetting, right? So you control fluids with electronics, and it's also pretty amazing. Please check it out. There's a great video. Of course, other electrowetting devices exist, but they're usually super expensive. So Urs kind of brought it down, really do a couple of $100, and it's open source. So I also big shout out to Shingo Hisagawa. He's also an amazing kind of hardware hacker from Japan, and he was also fascinated by the PCR, and he created the Ninja PCR, which you see two versions here. And the funny thing is, although he created the PCR machine and it's really amazingly calibrated and everything works perfectly, but he never ran a PCR experiment in his life. So only when he came to BioClub, and we ran a PCR experiment, and of course it works, you know, but he never did the actual biological part of pipetting and mixing and doing things like that. And actually, Shingo, during the pandemic, he put all his efforts into a so-called qPCR for detecting coronaviruses. You don't need a normal PCR. You need a PCR machine where you can actually have a little light sensor within the wells, so you can actually measure the amount of DNA. And he made an open source qPCR machine, which is called QNinja. And if you just look at the parts, it's about $220. And he's just in the final stages of development. It's working, but they're just trying to push it out later. So this is really, really an amazing thing, because as you know, qPCR machines usually cost thousands and thousands of dollars, and getting this to this price really enables Corona and the testing for other viruses, not in the first world, but it enables it in places where hardware is more difficult to get. But of course, you can also make this yourself, so it's also open source. And yeah, he's also this amazing person, and we're so happy to have him as part of the wider community. And of course, big shout out also to Philip from Bento. So actually, Philip, he started the Bento with the Kickstarter, but it took them many, many years to get it from the idea to the final product. So that some people thought it's a vaporware, you know. But he actually visited. He came he got some funding from a German foundation. I forgot which one. He came to Japan for 1 year, and he was our kind of intern at BioClub. And during that time, he worked very much to get the Bento lab ready. So that's us, and that's the Bento lab. And if you don't know the Bento lab, check it out. It's basically everything you need for a lab. It's again a PCR machine, a centrifuge, and a gel kit for separating and visualizing the DNA. And famously, George Church said, Bento lab is the Apple II moment. So if you don't believe me, please believe George Church. Yeah. So yeah, and this actually, because all my friends were so amazing kind of hardware hackers, and all my experience was just with basic stamp and a bit of Arduino, so basically nothing. But I was okay with programming, right? So I know my way around code. But this motivated me to join the FAB23 in FAB Lab Kamakura, and this was really a life-changing experience. So yeah, Riku is not here, but he's in another workshop. But it's amazing to have this group of very dedicated instructors to teach you stuff. And actually, what I did, I wanted to make a modular incubator for the home biolab. And it's only 2 years ago, but it still feels very naive how I did it back then. But hopefully I can improve it. So actually, I wanted to make it suspended from the ceiling, so it would look for its optimal temperature range, because it's hotter on the top and cooler here and stuff like this. So, but I'm still working on that. But of course, as maybe everybody and the new graduates know, your ideas for Fab Academy are very big, and then at the end they get very focused, you know. So I was just very happy it works and it heats and cools, and that's it. But I still, yeah, I was learning so much. And actually, these images are not good. But yeah, instead of instead of creating an incubator from scratch, what we're doing now, and actually this is Kat, hey Kat, yeah, and this is Shohei also from Bike Tokyo. So what we're doing now, we're taking an existing incubator, which is, it just costs like 100 US or 100 euro, I guess. And it's a perfectly working incubator, but it uses, of course, a blacked out big chip for control. So what we're doing now, we're trying to replace this control board with an ESP32, because then we get the internet access and we can not only monitor what's happening in the incubator, we can also remotely control the heating, we can put lights and so on and so on. And I think this this will be an amazing update to the thing. So I learned that you don't need to make everything from scratch. You can also just update and change things so to use it. Yeah. Yes, and I also want to talk a little bit. So apologies that we still have the I couldn't put the logo for the Bhutan conference here. So apologies. This is a thing which I presented at the Global Community Bio Summit last year, and this is it's called Bio Matsuri, and Matsuri is a festival. And we made these Bio Matsuri workshops for kids. So actually, this started before the Bio Club. So before we had a space, we ran workshops for kids. And we were invited by the Mori building, which is this huge real estate developer. And actually, they have some connections to MIT to make this workshop in summer for like 40 kids, you know. And it's very hard to entertain 40 kids at the same time. So we did 4 different activities like DNA extractions, verification, pipetting actually, PCR. And we had small groups with a teacher to actually engage them. And we always change a little bit what's happening, but basically to get them to do something, you know, so can be bacteria plating, DNA extraction, also making a clean bench, which is actually the Hello World. As verification is interesting, you use a sodium alginate to actually make little spheres where you can encapsulate bacteria and other things. Slime mold is their all-time favorite. Passing mammalian cells, this was kind of an advanced one, so working with actually animal cells. And of course, just pipetting and running a gel was great. And we dressed the kids up in little paper lab coats, so the parents could have nice photo opportunities. And unlike, how do you say, in Japan, kids or workshops are usually very structured. So usually you know exactly what to do. But what we are doing, we just give them a challenge, what they should do at the end. So when we ask them to make a clean bench, we just tell them how it should work, but we don't give any details. We just give them materials and the tools, and they have to do it themselves. So here, yeah, you got a fan to push the air through, a filter, and so on. So it's quite interesting because we had an amazing range of different clean bench designs. And then we had Tsuda-san, which is another very good friend of mine, and he's actually a professor, and we also got him dressed up, and his job was to actually test the clean benches and see if it works. And very often what happens, so there's no window or there's no way to put the hand in, but this, we don't call it a failure, it's a learning experience, right? And by doing, the next time the kid's gonna make a clean bench, they're not gonna make this mistake again, right? And it's kind of fun. And because I did bioinformatics 1 year, I kind of challenged the kids to do like manual sequence alignment, which, as you know, with DNA assembly, you get a lot of short pieces of DNA and you need to match them up to get a bigger thing. And we printed a lot of DNA sequences, and the kids were really poor, you know, that I liked it, you know, but the kids did not like it at all. So we dropped it the next year. Yeah, again, the slime molds. And the funny thing is, we also did it during Corona. And the funny thing is that it actually translated quite well to online workshops. The only thing we had to do, we had to prepare all the materials. They had to be sent out before, so we could do it online. But again, we did like small groups. We did again DNA extraction. and this is a kid in his house, and the first thing we had to do is actually make a tube stand, you know, and he made an amazing one. Yeah, yeah, there's Rico as well. Yeah. Okay. Okay, and now I just want to show how much time do I have? 20 minutes. Okay. So I just want to highlight one project we're working on right now at the BioClub, and this is called Mesomics, and we call it the citizen-driven genomics project of the meso microbiome. And actually, Nida-san Atsushi, he's a former colleague of mine from the University of Tokyo. He's actually a professor for cancer genomics, and I'm so happy that he also comes to our biocommunity space to do work there. So the idea behind this Mesomics project is that, so okay, for those who don't know miso is basically soybeans which are boiled, they are mashed, and they are mixed. Yeah, it's a very traditional, I think also other countries have it as well. Miso soup is maybe the most famous use of it. But basically you mix the beans with koji, which is another, I don't know how it's called in English, but I guess it's, yeah, here you go. Aspergillus oryzae, which is actually a fungus. And it transforms the soybeans, it kind of digests the shell of the beans and creates this uniform paste. And so this is basically the instructions how to do this. So you have the koji, the soybeans, the salt, you mix it, you mash it by hand, which is actually quite an interesting experience. You do this. And I don't have a picture of us making the thing, sorry. Yeah, okay, here you go. So we have this, we had to boil it, and then as a group, and Nida-san's partner actually, she's actually an experienced, she makes a lot of miso workshops. That's why it was quite a nice match. So there are special ways to mash it, to mix it, and actually what we are interested in and why it's called Mesomics is what kind of microbes do contribute to these miso fermentations. And what we're really interested in is if the human microbiome we have in our hands would actually be translated or transferred to the miso. And if we could establish a relation between the miso and the human who made it. So we are, the plan, actually we did the sequencing already. We now hopefully get the DNA data back. We did some preliminary 16S analysis, which kind of looked good. And we have the data, we just need to analyze it now, which is again, it's also an interesting teaching project because maybe not so many people know how to do microbiological analysis, so we're learning it as we go along, you know. So yeah, so I think this is a very interesting project that came out of the community and that actually expanded very much. And yeah, the interesting thing is that so for the sequencing is actually quite expensive, but we have some friends at other universities and they had some runs left over and we could do the sequencing there for free. So that's quite interesting. And finally, a little bit about the academies. So I talked a lot about, no, I briefly mentioned the Bioacademy, but I want to talk a little bit about the Biohack Academy. So as you know, the Bioacademy started, I think 2015, if I'm not mistaken, when George Church talked to Neil Gershenfeld and wanted to copy the model of FAB Academy to the bio domain. But of course, the problem was that for actually doing the Bioacademy, you would need a lab to actually follow along. And this is not so easy replicable like a fab lab, right? You can't just buy a 3D printer and a laser cutter and go on, right? So you need to have a kind of a higher investment to do this. And actually 2015 with Take was just here. Where's Take? Okay. So Take was doing the Biohack Academy and kind of I invited myself along to join him, and we had many study sessions, and that's also my first contact with the FAB Academy. But yeah, people could not follow the Bioacademy. It was great lectures by the experts in the field, but the actual hands-on part, you could not do this. You just didn't have the resources to do this. So that's where our friends from the WAAG came in. So I'm very good friends with Lucas Evers and at that time Peter van Bohemen. They also worked a lot with open source hardware, and basically Peter, he challenged, can we actually create a lab from the Fab Lab? So Hank, I have to talk to you. Maybe you were there when the Biohack Academy started actually. So I have to, this would be great, yeah? Yeah. So I think the first 2 sessions were just at the WAAG, but the third one, there was an open call, and we joined because at that time we did not have a lab. We had a community, we had weekly meetings, we talked about it, but we did not have a lab. So I thought it was actually quite a good idea to see if we can really make a lab from this. And okay, actually, so this is the, yeah, and there were, it's about 10 to 20 hours a week. It's not, the load is not as much as the FAB Academy, and it's about 3 months, and you have a lot of guest lectures. And the nice thing about the Biohack Academy, it's very open to extensions. So actually maybe 50% of the content we do in Japan is actually local content. So it's very adaptable. It lends itself to a more free interpretation of what's happening. Yeah? And again, we make clean boxes, and this time not with kids, but with adults, but the results are kind of not always the same, but sometimes the same, you know. So it's a very nice exercise. And of course, Foldscope, all-time favorite. And we actually assembled the Pocket PCR from Urs, and you have to bear in mind that people who do the Biohack Academy, they can have a FAB background, but many of them also didn't never do soldering, right? So this is also an interesting introduction to soldering and things like this. And it's quite interesting if you assemble something and then run the PCR and make it happen. And this is a joke that only Japanese speakers get. Okay, no Japanese speakers here. But kombucha in Japan is something else. It's a salty soup made of seaweed, right? So when you talk to Japanese about kombucha, they say like, what do you mean? So it's called, so the kombucha we know is called Kocha no Kinoko, and basically what we did here, we tried an experiment where we mixed the Japanese kombucha and the Western kombucha in different quantities from 100 to 90, 80, and see what kind of results come out, you know. So it was quite, so you see the colors, you know, of the gradation. So it's of course, kombucha makes SCOBY, and SCOBY is biomaterial, so maybe most of people are more familiar with that. And yeah, we do DNA extraction, we do PCR, and actually at the final projects at the Biohack Academy are bacterial transformation and actually CRISPR experiments. So, but again, for that you need a biosafety level lab. So it's quite a long journey, and I think Kat, we did not finish yet. I think we have the deadline of Maker Faire, Tokyo, autumn, and there you will see Kat's final project, you know. No, of course, but Kat was really amazing this year. She did FAB Academy and Biohack Academy at the same time, you know, so yeah, well done. I want to show 1 or 2 examples of the Biohack Academy graduates from last year, and this is actually Chupa Yokogawa. He's a musician, and he was, again, very taken by Urs's Pocket PCR, but he also quite likes theremin, you know, and theremin is, of course, the music instrument that works. And you already know where I'm going with that, no? So basically, he managed to connect a theremin to a Pocket PCR, and the only way to run a PCR experiment on his PCR machine is by doing that. So you control the temperature by hand movement. So this is 94 degree, need to hold for 30 seconds, 74 degree, maybe 1 minute, 56 degree, maybe 1 minute and a half. And then again. So it takes 2 hours to do this, you know. So he's a musician, he's a performance artist, so he's performing the lab instrument, and it worked as well, you know. So it's quite interesting. And it's not here, but actually the video looks also exactly like that, you know. And I also shout out to Joske to Chia, who was actually my instructor at FAB Academy. And then the year after FAB Academy, I was his instructor at Bio Academy. So for those who don't know, actually, this is the Fab Lab Kamakura. So it's this amazing old building. Please come to Japan, please visit us. And he, of course, having the experience of FAB Academy, he went all in. So he made a Fab Hack microscope, which he basically built from scratch. And he made a very good documentation of all the boards and all the optics. And so he got it done to move only in the Z direction, but this was just done in 2 weeks, right? So it's a really amazing thing, and it's a very amazing example how the Fab and the Bio can actually come together. And okay, I think that's more or less the end. I just wanna finish with some kind of historic family pictures. So this was the BioFab and Convergence in Geneva in 2017. Again, we have Mark, we have Urs, we have Philip, we have the whole European bio scene. And interestingly enough, also David Kahn. So that's where everybody met David. And this was in May, and David really liked the idea of people coming together. And what happened in autumn, we had the first Global Community Bio Summit at MIT. So David had this amazing feast of bringing not only Europeans, but all the global people together to have one amazing week at MIT. And again, yeah, here's George Church and this. And actually, this was the only year we could make a proper picture, because the next years, I think it was 100, 120 people, but the following years it was 300, 400, 500, and it's really hard to find these pictures, yeah. And yeah, and again, another family picture of BioClub Tokyo, again with David. And this is Take-san. Yeah, he's somewhere as well, yeah. Okay, that's it from me. And we're gonna have an open a panel this Friday from 11 to 12. And everybody who is interested in bio, who does bio, please come. We're gonna make it a very open session, and we can go more into detail how to enable bio in your Fab Lab. Okay, thank you very much.
Thank you, Georg. Do you guys have any questions regarding his presentation? Any comments, suggestions? Okay.
Can I help?
Please come, yes, yes. You should come to Tokyo. Huh?
Okay, so the actual question is, was there any electronics circuit that was hard to design so far, or?
Yes, so the incubator is still we're ongoing. It's basically a matter of understanding what the actual board does, and what it's doing. But yeah, I'm happy to share the things with you. And actually, I didn't show this today, but what I'm doing now. There's like 96 well plates, right? So these plastic boxes with micro wells, and some of them are transparent. And a friend of mine, he's from, where's Timmy from? From Barcelona. He's doing PhD in Barcelona on synthetic bio, and he has this crazy CRISPR experiment where he wants to make light-controlled CRISPR. And I said, okay, we can do light control, so let's just put NeoPixel on the bottom of it. And I used SVG PCB.
What?
To design this board.
Are you serious?
Yeah, I can show you later. Yeah. So but it's not working yet. But because it's a very pattern-like thing. And SVG PCB is very nice to make repetitive things, So,
Amazing.
But yeah, maybe I need your help with that. Yeah.
Yeah. Mike.
You showed the kombucha experiment, but you didn't tell the outcome. So what was the outcome of the kombucha?
The outcome of kombucha is always very fluffy and very slimy. but actually, but each of them created a SCOBY, each of them created a material, but it was small things, and it would be great to do a more controlled experiment, actually.
Japanese kombucha one look worse or better? Or
The Japanese kombucha is salty, right? So it does have a lot of salt in it, and if you mix it with the sweet other one, but it would be great to analyze what actually bacterial communities are inside there. Yeah, of course it tastes horrible, no? At least for my taste.
I'd like to ask about experiences and if it's challenging to cooperate with institutions like education institutions, universities, or research institutions, or if you have any experience with that.
In generally, or
Yeah,
yes, I have a lot of experience. Surprisingly enough, most universities, most researchers are very open, very happy, right? So if you contact them directly, they're very happy and very supportive. Early in my career, if you want to call this, it was funny because the scientists were interested, but the university level were not interested, right? Because, oh, you strange artist, you just make like green bunnies, and then we have, that's kind of, yeah, that's a different story. But I'm also a visiting researcher at Waseda University, so we have a professor there doing cyanobacteria, like circadian rhythm on cyanobacteria, and he's very welcoming for artists. So I'm also since like 12 years a member of a visiting researcher of his lab, which is great, but it's within a university, right? So to get community in, it's very difficult. So, but yeah, you should just ask, yeah, and it's surprising how open people are.
okay, thank you.
Yeah.
Hi, thanks very much. Very interesting and very inspiring to see. I wonder what you think about, so if you can hack a fab lab and make a lot of the machines, and you probably can hack a biofab lab and make PCR machine incubators, how do you get around the consumables of a biolab, such as primers and sequencing? And I see you've done some stuff, and actually we like the fact you said some researchers had sequencing runs they didn't use, and you kind of just slipped into that. What are your thoughts about how people can do it yourself and figure out the consumable part?
Yeah, this is actually we talked about it before, but this is a very interesting question, right? Because most of the hardware hackers, they make the PCR machine, right? It works, But where do you get the chemicals from? Where do you get the reagents from? And especially in Japan, we have a very strict situation which dates back to the subway terrorist attack from the 90s. So it's not possible for individuals to buy reagents. So whenever you want to buy reagents, you need to go to a special company, and they only sell it to other companies, right? So that's another reason why we actually made the BioClub, to have some sort of legal framework where we can buy reagents, right? But of course, we talked, there's Jenny Malloy and other people who actually look at the pipeline of how reagents are made and distributed, and how this can enable things. But because that's, of course, you have the research-grade reagents, which are very, very expensive, So the companies, they also sell like sucrose, 1 kilo for like 35 euro. And you know what sucrose is? It's just sugar, right? But it's research-grade sugar. And it's, so, but for biolab, for DIY biolabs, maybe you don't need that high level, right? So you can get away with cheap alternatives. And that's another thing. We at also the Biohack Academy, there's a big thing, how to make DIY medium without using the reagents, but with household items. Yeah. So, but yeah, if we should have an answer to that, but we don't know yet. Yeah.
And making your own reagents is legal?
Legal?
Well, if you can't buy them because it's illegal, really, and if you make them on your own, is it actually okay?
No, for example, for if you want to make PCR, you need the polymerase, right? Which is a protein, and you can create, so you can have certain plasmids. I guess, actually I don't know, but I guess you use E. coli to create this protein, but then you need to purify it, right? If you're in a lab that has a biosafety level 1 rating, you can do it.
Okay.
If not, then not, right?
Yeah, I know nothing about
but
biological labs.
It's not. Yeah, I don't know. But of course, it's legal to do it.
Okay.
As long as we follow the genetic modification guidelines.
Okay.
It's basically to answer your question. You can do it, it's just difficult.
Yeah.
And all the patents on tech polymerase are already gone because it exists since the 90s. But it's difficult.
Even since the 80s, right?
Yeah.
I think they got a Nobel Prize in the 80s. But it's
So you're allowed, but it takes a lot of practice, I
I mean,
think.
you can buy it for like 10 euros, or you spend like 5 weeks making it, So Yeah.
I don't know. Just a quick question regarding you mentioned patents. Is that really an issue if doing art?
Patterns or
Yeah, the patents. Yeah.
the patterns for the flowers and things like this.
Yeah, what you just mentioned that you were creating some stuff and the patents ran out, so it's no problem. But even if they didn't run out, couldn't you just do it?
For the reagents?
Yeah, or anything. Yeah, and if you're just hacking around and
Actually, I think that's the freedom of art, right? So you don't. For example, these flowers, if we would sell it, this would not be okay, right? We could not sell it, but we could use it for artworks. So maybe if reagents is the same, right? So if we just make it for our own personal use, it's okay. But yeah, if the patents ran out, then of course you could do it.
Have any further questions? No. Okay. So for Georg and everyone's attention, I'd also like to mention that at the CNR Center for Natural Resource Lab in Punaka, we're setting up a bio lab, and hopefully somehow we can collaborate together. Of course, I'll help you link with the person who manages the lab.
I met already.
Oh, that's great news for us. So EOL here has been really helpful for us in terms of setting up, of course, with the whole FAB Foundation team, and we're really grateful to that. Anyway, thank you so much, Georg, for your time.
Thank you very
Thank
much.
you. Thank you, everyone. Oh, I think Nanda has a question.
Okay,
And
one more.
she has a question as well.
I just want to add something because you didn't, when you asked about academia and with research and what the experience is working with other universities, I just wanted to add that when we're inside of BioClub, Georg is not only part of other university labs, but also the Vaseda lab also is like a genetic committee of BioClub. So there are, so whilst normal people cannot enter academic labs to do whatever experiments they want to do at university laboratories, the kind of special thing at BioClub is that we have academic support from professors who donate their time and being our committees, but people from the general public can walk in, present their idea, and then we help them do it as long as it's completely transparent. So it's kind of a middle step between being, like it's between the rigidity of academia with the supervision and being a DIY lab in the basement. That's kind of what's so special about it as a space. Also what makes it so special for artists like me when Georg gave me a home at the biolab.
That's a very good point. So Hideo Osaki, who's the professor from Waseda University, he's also very, very supportive. He's the scientific supervisor. He's on the GMO committee. And also without him, this would not happen. Yeah? But we have also Shohei, who's a PhD. So we got this amazing growing community. Yeah.
Hello. My question is regarding the case study of the kombucha here in Bhutan. So actually, one of my friends have started doing, he's an entrepreneur, and he started doing the business on the kombucha actually. And that idea he got from the FAB Lab Bhutan actually. So, and he started to like sell the product about the kombucha, and he had faced a lot of problem related to protocols, regulations, because the people are very new. Kombucha means it's like totally a lot of like fermentations, a lot of bacteria, so many things. And then he had one issue with the form, but like he got a problem like convincing the people about the kombucha, about its health benefits and all. And he was like totally like his entrepreneur business got totally shut down. Because so in that case, how would you like suggest like in our context here in Bhutan, like?
Yeah, so of course one thing what you do in the lab is one thing, right? And you can make this strange mixture of kombucha, but if you want to sell it as a food, that's a whole different step, right? Because then there's food safety, food health, and so on and so on. So of course we want that our food is safe, right? And how can we ensure that it is safe, especially when you work with bacteria cultures? But it could be interesting to think about an easy testing method that actually would show that there are no dangerous bacteria in your kombucha cultures, and therefore it's safe for humans to drink. Yeah.
So in that case, like a lot of sugars are added on, like in the process of building up the kombucha, and then like so is there any like case study, like successful case study where the people like no, if you could suggest us like.
I wish I know. Actually, I don't. I think most kombucha is actually pasteurized. So I don't think it's still alive.
Yes.
So maybe some yogurt. It is okay. Maybe some yogurt have active cultures, but only one culture, right? So it's. Yeah. So actually, so many spaces we are interested in this layer, which can be used for materials and maybe not so much for drinking. Yes.
Yeah.
But yeah, I'm looking forward to hear more about your
Thank you.
challenge.
Just a quick question to elaborate on the academia collaboration with academia. Where have been the major challenges or the most interesting? And one specific question about, I was surprised to see Waseda University. I graduated from Tokyo Tech, so I just wanted to know, like, if you
Okayama?
have, Okayama campus, yes.
Nice.
So I was surprised to not see there because I would see like it's completely relevant. I would like to know why or if there has been any challenge.
So of course, Professor Hideo is also a very, very old friend of mine, and he invited me when I had, when I came to Japan. I had an artist talk, and it was supposed to be for 45 minutes. We talked for 5 hours, you know. Yeah. And then a couple of years later, he kindly invited me to his lab at Waseda, right? So it's really about the person who opens the lab, you know. It's not an institutional thing, you know. And I have friends at DI Tech, but they. Actually, also one of the advisors is from DIATEC, you know, but there's also interesting things happening there, but maybe we still have to explore this
they have
connections.
Been open. Hopefully.
Yeah.
I wanted to ask if you have some biochemistry background. Maybe I missed, I was not in the beginning. And is it required because you said anybody could come and also experiment? Do you need also to? Okay, but does it also, like when you start getting into it, I guess you want to have studies also on biochemistry after, because it's becoming.
So basically, so in my high school, it was kind of a science high school, so I always had this, and actually I did study biology for 1 or 2 years, but then I realized I tried to study computer science, biology, and art at the same time, but it was too much. So I just said art because there I can do whatever I want. So I have a little bit of background. But actually, what the Bioacademy and the Biohack Academy gives you, they give you also a very good primer about the basics of biology, right? So you will learn everything. In both courses, all the content is online, so you can just go and watch the amazing lectures, you know. But what we do for the lab, if somebody wants to use the lab, we of course do an onboarding. We do an instruction because you need to learn lab safety, what to do in the lab. And of course, usually people come with an idea, right? So I want to do this and this and this. And then we try very hard, we try our best to support this idea.
So much like the FAB Academy, the Biohack Academy gives you like intro to like biolab etiquette and like biolab skills. So you have like multiple weeks in it, like, and it introduces you to it. So you basically go from zero to knowledge, much like you do at FAB Academy. You know.
Sorry, we just have 2 minutes, so I'll take in one more question. Maybe after that, we'll go out for a separate discussion. Yeah.
Hi. So I had a question regarding same Biohack Academy. So I know that there used to be a course called Bioacademy, and now I think it's not there. So I wanted a question about Biohack Academy.
Yeah.
How can is it a completely online course, and is it like how's the structure?
So there is Bioacademy, but
it's in US, right?
So AL is from Bioacademy, and they used to be the same structure as FAB Academy, but now they run it together with the MIT students, and you can be a global listener.
Okay.
Right? That's the Bioacademy.
I am asking about Biohack.
But you will make a workshop tomorrow where you will show some remote controlling of lab machines, so you should go there.
Yes.
But the Biohack Academy, it's same as FAB Academy, right? So you have the online lectures, but you need a local lab.
Yeah.
To do it.
How do we initiate that? Because I'm from Little Mumbai and we have a bio lab. So
Yeah.
how can we initiate that?
Talk to the WAG or talk to us. Yeah.
All right, thank you. Thank you guys so much. Please give a big hand for Georg.
Thank you.
Okay, so the next session we have Dr. Yogesh Kulkarni from the Vigyan Ashram in India. So he's a director at the Fab Lab Vigyan Ashram. So they've been mainly focused on innovation, sustainability, community building, and they also have a lot of projects revolving around agriculture, or be it like management of nature and stuff. So please let me know once you're here. Anyway, please give a big round of applause for Mr. Yogesh. You, Mr. Yogesh.
Yeah. So good evening, good afternoon. I hope like some of you are here who are interested in this topic, which I'm going to present. I'm going to talk about a self-sufficient village, which I am trying to practice in my village. In fact, so far we have not pledged in the Fab city as a Fab village. Though like I was told by Thomas many times to sign a pledge, but I was like, I'm afraid of committing unless I have a concrete to show something. So I said, let me see what I can do and then I can do it. So from 2017, we are working on this project and I'm going to show the progress we had made in these self-sufficient communities. I am from Vigyan Ashram. Those who don't know about Vigyan Ashram, we are located near in Maharashtra in India. It's near Mumbai, almost 300 kilometers from Mumbai. And it's a small village. And we have our Fab Lab located over there. And as I told you, like, I'm impressed with this whole initiative and the philosophy behind this Fab City, mainly because it talk about distributed production, local production, and that attracts me more than the smart village or smart city, which only talked about data and various kind of gadgets. And those of you who are aware, like in India, we have the Mahatma Gandhi, who was the founder of our nation. He is strong proponent of the self-sufficient village. So he always says like the village has to, if the country or the community has to develop, then all the goods and services necessary for the village has to be grown inside that community. So the Fab City was very much within our kind of philosophical thing. And therefore we thought of having a Fab village. Why Fab village and not Fab City? Because in India, we have approximately 4,000 villages, which has population of more than 10,000. And that comprises of almost 70% of the country that stay in the village. So instead of looking for the cities and making them a self-sufficient, if we start making the 70%, which is bigger chunk, it makes more sense. So I started talking about Fab Village. But as I told you, like, I want to prototype it. I want to try it myself, how to do it. And yes, there are like many kind of resources, how to do it. And so we decided, like, at least let's try in these 4 components to become a self-sufficient. The water, energy, agriculture, and waste management. So we took these 4 things, and let's say at least work on these 4 areas if we can become a self-sufficient. But then I found my village, Pabal, is also big. The Pabal village has a population of 10,000. The village of around 3,000 hectares. So I said, forget about village, start from my campus. It's a small community of 100 people. So let's see basically if we can make our own campus self-sufficient. And therefore we decided to make a plan for our own campus for next 5 years. And we did it in 2017. So this is what we started doing it. And then for each of the area, let's say energy, we put up a target. Like we want to reduce our energy bill 10% every year. Like though our energy requirement is increasing, so let the energy requirement goes on increasing, but we'll still put a target of reducing it every energy bill by the energy company by 10% every year. And then we made basically a various plan how to reduce the consumption. So it was a plan we made and we started following it up. First of all, like we went on a DC. So all our AC appliances, wherever possible, almost everywhere, we started putting them on a DC so that we can reduce the consumption. Wherever our consumption is less than 200 watt, we went directly on a solar energy without using an inverter. So we just say like during the day, we don't need to use anything. Directly we can harvest sun energy and we can run our appliances. For example, polyhouse. The polyhouse requires the fans to run during the day. So we need fans only during the day. So we just use a converter, a solar panel, and we started using it directly on the DC. Then the solar net metering, we went for that. And wherever possible, start using a solar thermal energy, mainly for cooking and heating water. And we did it step by step for all the 100 people, our kitchen, our hostels, so we practiced that. And we are able to reduce our energy bill a lot with the DC solar heaters, DC fans. In fact, today we are an energy surplus. Like we produce more energy. In fact, even for the solar, we have excess energy. And when we started getting excess energy, so far Vigyanashram doesn't have a transport. So now we started putting an electric cycle because we have free electricity now, because we are energy surplus. We have an electric rickshaw. So we started electric rickshaw moving around the village. So we got 2 electric rickshaw. We got 4 electric bicycles to move around. So we are an energy surplus. So we found more options to consume the energy. Yeah, I told you about various solar gadgets we made, like for polyhouse, for the display units. If you visit our links, you will get all the details, like how we did that. I will introduce you all the what we had done, and maybe during the discussion I can explain it much more. So these are all solar thing we did. Solar air bubbling system for the grey water recycling, solar control polyhouse, solar on-grid system, swing machine on the solar. So we only work during the day, not during the night. So we can run directly on the solar. We have solar milking machine. We have solar refrigerator, solar lighting. So by putting mix of this, at least for this 100 people community, we are at least we are able to become a self-sufficient in terms of energy. So these are more application, like I already told this one, solar water pump, solar, the computer center on solar. So this was first objective. We are working on it. Second, we want to become we don't want to produce trash. We want to become no waste to be generated from the campus. And then again, there is a weight garbage, there is a plastic. And of course, we created something like a scrap bank. Like we will not throw something out, but which is we can reuse it, or we can do something with that object. We put it in the bank. So we call it as a bank because we can just sort it out, put it properly. So next time when we want to make it, the scrap bank, we can use it. And the scrap bank material is free. So weight garbage, again, there was like a two thing, like one is the kitchen garbage. So we designed this composter, and we also got the culture from the Bhabha Atomic Research Center to make the compost culture. So within the 30 days, we can decompose everything. So one family of 5 people, approximately 1.5 kg weight garbage per day, we can use this. So we made this weight garbage, the composter, and with the help of Dassault system, we said we want to test it on a big scale. So support us for a 50 numbers of the weight composter, the weight garbage composter into the field. So they supported us, we put it into the field, and they are working. So at least on our campus, now we are able to use it. And of course, since the technology is developed, we started selling it. So this kind of we have all the designs, manual, everything is done at ashram. We made this kind of it's in local language, a communication material, and we started selling it through a company. So it's a separate startup come up, that Greeny, the name of the Greeny is the startup. We started this selling composters. When we started working with the weight garbage, see, one thing leads to another. We started to make only our campus self-sufficient. But when we started getting expertise, we started getting calls from other people. So from the nearest town, we got a requirement. Can you help us to make our city clean? So you are doing something. So we started working with them. So it's, of course, because of the knowledge we earn, we design various composters for them. Basically a medical waste hygiene box for the garbage disposal van. So we made many things. And this is like for the town, Sasford Municipal Corporation, we help them to get the green brand. So they are labeled as a green town. So whatever the piloted we at Vigyan Ashram, we are able to scale it up or implement it into the nearest things. It's since last 6 years. So this is a certificate from them, like they got. But kitchen composting is one thing, but that's not sufficient. And the composting doesn't have that much of value in terms of money. We also want to have some money. And therefore, we are trying for some other option as well. One of the things, we also started using the biogas. We already had a biogas, but we started working on its efficiency, how to use it productively. Through all these efforts, we got this model, we made this. And again, one of my students has come up with a startup, and he got this Kisan gas. So again, this weight, the garbage recycling, we come up to this place. Another area of recycling is the agro waste. We are in a village, we have a farm, we got an agro waste. And we want to do the compost of that also. Otherwise, farmers generally burn it out. And so we decided to go for the agro waste composting. Thomas is here. I was telling them like how we started approaching the make a fab village and why I'm afraid of signing a pledge. So I told them like how we become an energy kind of self-sufficient. Maybe I will explain it later. And now I'm telling about the weight garbage management. Agro waste composting, we started experimenting. We got various culture from various organizations. In Vigyan Ashram, we put various beds to find out within how much time we are able to compost it. We started doing it. Our results we are able to work with 166 farmer. Like we did in the Vigyan Ashram our own waste, but by looking at it, we are doing it successfully. And it's a small culture. You can just copy, you can take it. The culture is like a curd. You take a spoon and you can replicate it. So we just give this culture, and last year, 170 ton of biomass, instead of burning it, we are able to convert into a compost in 45 days. So this like start with a small action at the village level. We have a hostel, ladies hostel of 16 girls. They stay on the campus. It's a small hostel, 16 girls are staying over there. And the problem of disposal of sanitary napkins was there. We purchased the electric incinerator, but it was very costly. Not for the cost of the machine, the recurring cost of the electricity consumption. So we were just looking for alternative ways. And we came up with this LPG gas incinerator. We made it for our hostel. It's all designs, everything is ready. It's now, we went through many iterations of it. But I was telling you, like we started with the making our own campus self-sufficient. But it gives us a new idea and new opportunities. So we done with the 5 pads per batch. This one is for the 50 pads per batch. And it was by the nursing college in a nearby town. They gave us an order to make a 50 pads per batch incinerator. And we are able to make it. So this gives us a new ideas and new kind of technologies. We did a survey how to do work with the plastic. We did a survey of the village. 800 kilograms per month we are generating. It's a very small amount to basically transport it to a Pune, a nearest city, and get it recycled. But that 800 kg is sufficient to make our all village dirty. Even our the all water stream get polluted with that. So at 800 kilograms, you can just see it everywhere. We started to what to do with that. Again, one of the solution of plastic pyrolysis. We started working on it. We still don't have a success. We are able to produce the oil, but energy balance and the cost of operation, we are still not able to meet it. So we are working on it. In fact, there was one student from MDDI, Chetan. We also gave him this project. So we are just trying out different projects with the students to work on it. The garbage thing is still not over. We still want to make a money from the garbage because we thought whatever food, kitchen waste, it has the protein and we are not able to harvest it. We are able to make a compost. It goes to the plant, it's good for nature, environment, it's okay, but it's not a money. And especially the fish waste, chicken waste, the slaughterhouse waste, that was again a problem for our village. Of course, in Vigyan Ashram, we got a very small amount, but when we look around the community, that was the problem. So we came up with this, we found out this black soldier fly, which is not very common in India, but elsewhere in like Philippines and Vietnam, I found many references, many videos, many DIY things. We learned from them. We got own BSF chamber. We design it. We have own controllers to keep the data. And at present, 60 kg per day kitchen waste, we are able to consume, like my larva. So whatever like BSF are there. But problem is that larva, many places you can eat it. Maybe as a puff larva or something. But in India, it's not like culturally, nobody likes to eat that BSF larva, though they are very protein rich. Then what to do? Then we thought of feeding them to our poultry, to our chicken, the chicks. We started feeding it to our birds, and the birds are giving us eggs, and they are acceptable form of food item. So we get eggs, we reduce our food cost. And last year when the soybean prices, soybean is the main ingredients of the poultry feed. When the soybean prices went up, we found this larva as like a cost saving options for us. So now we are doing it bigger scale. In fact, we went to nearest town Rajguru Nagar and we asked them to give us a place so that we can grow more BSF larvae and we can give more feed to our poultry. So there are many interesting projects like this started coming. Water. I talked about energy. I talk about the waste management, what we are trying to do in different ways to make it a self-sufficient. Water again. See, we are a drought-prone area, and as per a Government of India norms, every person get a 65 liters of water per day per person. So we need to manage everything, including bath, washing, clothing, everything, cooking in 65 liters. So that's a norm. So to manage in 65 liters, it become a task for us. Like we don't want to use more water than the norms because otherwise other people will get deprived. So we started first of all measuring the waters, to metering the water and giving it to per person. So that system we developed. Yesterday Suhas has conducted the session on the water filters. We have made our own water filters. We went through the many kind of a water recycling system, like RO, which become fashionable, reverse osmosis in our village. But it basically throws out a lot of water. And our TDS in our water, like our water doesn't require a reverse osmosis treatment. It only need to be filtered with the whatever the sediments are there and what is the bacteria is there. We need to only kill that. So we said, okay, we will make a filter only for our own requirement, and we made the filter. Yesterday we conducted a workshop also. We have a manual how to make it, the filters, which has a UV, which has the different kind of a filter out the sediments. We have designed that. The grey water was another interesting stuff we work on. I will refer it tomorrow also in my presentation. We started working with the various kind of grey water recycling systems. We studied them. They are either costly, centralized one, required a big water like a STP, sewage treatment plant. We want smaller unit for the decentralized houses because we are not centralized. Each house has its own soak pit where they discharge their grey water, and that water just goes into a drain, and we want to recycle it again and again. So we work on it. Of course, there are many experiments and many projects are there, at least 3 academy projects for the grey water. I can tell you how many projects the students work on it. So 3 academy projects for grey water recycling, and of course many other students. And finally, we are able to design a system which is a modular, which you can make it in a factory using this IBC tanks, and the 6,000 liters per water. Like we are recycling almost every water, every drop of water in Vigyan Ashram. Now we are working on a black water. So black water we still not done it, but we are working on the grey water. We are successfully. I told you about the filters what we made. We made the filter for ourselves. So all the filters in Vigyan Ashrams are made in Vigyan Ashram. We study the technology, we adopt it from others, but we said, okay, we'll make our own filter instead of buying it. And when we made it, we found the cost comes down so much. We also conducted a workshop for the girls to make their own filters and take home. So that, of course, again, that was supported by Dassault system. SolidWorks, they give us some money. We also thought of, let's the villagers know how much water is available in village. And at least Vigyan Ashram people know how much water is available in our well. So we have a lot of data. How much, like we take the data reading every day of the water level. So depending upon how much is the rainfall, we know how the patterns of the groundwater level operates. So we can estimate, like if there is a 500 mm rain, then the water will last up to April, and we will get the water will fall down like this. So we made that system. So we can put there is a display, this kind of thing, which says how much water is available now for us to use. So at least before the water getting exhausted from the well or the storage, we will be able to make it. So we made it for our well. Now the plan is for the village. I already talked to about measuring and metering. That NEER is there, controller. The fourth component of the self-sufficient village. First, I talked about energy. Second is waste management. Third is about water. And fourth is we want to make doubling the farmer's income or making a self-sufficient in terms of agriculture. So we have a very limited farmland and it's not sufficient to feed 100 people. But then, therefore, we decided we'll not focus on the feeding, making self-sufficient the campus in terms of agriculture, but we will generate more income from whatever is there. Whatever land we are using, we will able to harvest more. So that we started. And we started with basically the polyhouses, then aquaponics, hydroponics, soil fertility. I already talked about in composting. So we put these three as an agenda. Even for polyhouses, we said we'll not go for any other crops. Let's only focus on capsicum because capsicum is in our area, it grows faster. So we said we'll not talk about anything. We'll see how much more we can produce in capsicum. And we will only create conditions for that. So we made only that is the project. Suhas is working on it. We are presently generating a lot of data on this, growing the capsicum more efficiently, using precision farming. In our own polyhouse, we practice this hydroponic, aquaponics. And these designs, we put it online, like you will able to see what we are doing. But only telling, like making it also not sufficient. We want to talk to the people, communicate to them. On this Sunday, we have an exhibition in Vigyan Ashram. Every year on 30th of July, we call people to see what we had done. And we put posters like all our data, we just present in front of them. And the people, community people comes and walk in. So last year, we asked them to make a compost. But we want to tell them like how much, what is the benefit of using a compost? Otherwise, you collect all the wet garbage, you have all the agro waste, you make the compost of it, and again you apply it, but what is the benefit? So we had done this control and experimental trials in our own polyhouse, and we found like the tomato crop, 34% there is an increase, 51 for the brinjal, all these things. So this data is also we are putting it so that they can buy it and more people can adopt it. So that we are doing. The self-sufficient village also has like an education component. And at Pabal, Vigyan Ashram, we run a FAB Academy, we run the MDDI course. So it's possible, like for good quality education, you can come back to a village and you can get it. So I will not go into it. But still, when we do it in Vigyan Ashram, that is also not sufficient. People will say, okay, you are staying over there. You are controlling everything. You got a qualified manpower. Therefore, you are able to do it. And therefore, I went to this, again, Dassault system supported us. And I said, I want to experiment it in a nearby school, which doesn't have any technology background. And I want to apply whatever I am doing, developing it as a technology, and I'm claiming like this will work. I want to experiment it somewhere else. So we selected this village, a Mukhai village, which is 7 kilometers from our location. So not too far, not too close. And we are started experimenting with this. So this is like we got support from La Foundation for taking all the technology what we had, I mentioned to you, to other place. And whether that campus of Mukhai school can become a self-sufficient. Because if you are able to do it, then in the workshop, I was there last time, somewhere was talking how to convince the politician. So I feel like when I have these few examples, the people will come. Like on 30th July, the politicians will come to see what we had done. And then I'm in a better position with all the data, all the technologies available to convince them. So we have we have a hydroponics in the school. We have a grey water recycling system in the school. So whatever we had in Vigyan Ashram, we put the water filter. We involved the students, local students, to make this. So they made the filter. The composting, they made it. They also got a mini fab lab. So they also got the tool because they want to make everything. So we are giving them a design. So we do it in Vigyan Ashram. We are experimenting, we are iterating. And once we feel, okay, it's okay, I should be able to taste it in my vicinity, not too far. So that's why we selected this village, which is our in control. They are supporting us very well. So basically, like when I talk to the people about this project with the Indian Institute of Technology at IIT, or I talked about with the Dassault system in Pune, I always say like the cities are for the people who cannot afford to have a good quality of life. Because in the village, see, my house and the lab is like less than 50 meters. So lab is there and I'm staying here. The students who stay on the FAB Academy, they stay next to me. So we, again, the fresh air, lot of oxygen, everything is there. You get a connectivity, you got tools. You can meet many of you basically online. The Neil's class every Wednesday, MDDI course. So everything is possible by staying in a village. So it's possible, like if you get water, you have a food, you have energy, so it's possible. So we are working on that. So that's it from my side, like that's what we are doing it. Those who came late, I will just show the first few slides of the energy, and then maybe we can discuss. So initially, like I told you about, this is the inspiration for us, Vigyan Ashram being a Gandhian thought institute. This is what he has said. Like the all and goods and services necessary for the village has to be grown within the village. So I gave a reference of Fab City, but I also talk about Mahatma Gandhi, so that at least I can connect with the people, they know what thought process I'm coming from. So I told you, like we were just, this is our things, 100 people, campus, want to make a self-sufficient. For the energy, the 10% every year, a reduction in the bill, electricity bill, that was a target. So first we did with the use of all the DC equipments. Those equipments which are less than 200 watt directly go on solar without any kind of only controller we used. Solar thermal gadgets, solar dryers, solar water heaters. Then we have a solar polyhouse. We got net metering. We are feeding it to the grid. We have solar sieving machine, solar polyhouse, solar bubbling system for our grey water recycling. We have solar milking machine, solar fridge. We have a solar display. So and they are all directly, basically not a net metering. We have a solar pump. So by doing this, we become an energy surplus now. We started in 2017. So from last 6 years, we are energy surplus. And when we become an energy surplus, we want to use it more energy. And then we realized we also did a comparison with the induction cooking and the LPG. And we found induction is cheaper. It's more efficient. Now we are going away with the LPG. We are going for induction cooking. Then we bought electrical bicycles because we got a solar energy. We have electricity now. We want to consume it also. We got electric rickshaw for local communication. And so that way for energy, for our transport, we are trying to become a self-sufficient. So these are the 4 domains we are trying on. So that's what we are doing at Vigyan Ashram. And I'm happy to share whatever the designs we had made, the projects we made with all of you. Yeah, so thanks. This from my side. I'm open for questions, comments.
Yeah, thank you everyone.
What? My contact, okay. Yeah.
Meanwhile, thank you everyone. Mr. Yogesh, we have a question from our live streaming. The first one is the composter design insulated? from one of our online viewers here.
Yes, please.
Yes, it's
What
a
is the-
question online, and it
What
says,
is the question?
Is the composter design insulated?
No. No.
Okay, it's
Yeah.
not.
It's not.
And the second question is, have you measured the
It's a-
composting temperatures reached?
It's basically it required like there is a thermophilic phase is required for the growing of the bacteria. So it requires air. It requires mixing with the kind of the culture. So it is required. So aeration is there. So the composter, if you see, if they can send me an email, I can share the designs with them. So there is a manual of how to use it. But yes, we measure the temperature. It can go up to 60, 70 degrees. It's there. Like you can feel it hot when if you put your hand inside the compost, and it smells like if you smell the soil after the rain, it smells like that. Like if you went to a farm. So yeah. So ask them to drop me a mail. I will send them a report.
Sure. So for all the online viewers, we have Mr. Yogesh Kulkarni's email address and Vijnana Ashram's web link here. Now to go to the live audience here, do you guys have any questions? Oh, a lot. But this is good news. Who wants to go first then? Okay, you're the closest to me, so.
Okay, thank you, Yogesh. It was very impressive, the enormous amount of complex projects. So my question is, how did you organize this all?
Okay. See, Vijnana Ashram is an educational institute. So I am a teacher. I'm not any kind of a thing. So I'm a teacher. I have a lot of students. They come to me to do the projects for their academics help. My only skill is basically I give them a task, channelize their energy, ask them to work on different real life problems. So that's what we do. So this work, I was showing many links to you. So they are the blog of individual students who work on the project. And when the student goes out, after his academic period is over, I take that thing and give it to other and ask him to continue. So it's like a relay race. So my skill is only to basically take whatever work has been done by the one student, give it to another, again, and then take a credit. So, so it's basically my student who has done it. So there are many, like I gave the reference. So yeah, so like for composter, Akshay is the one who work on it. So we name the composter with his name, like Akshay Composter. Dhananjay, who work on a biogas, he started his Kisan Gas startup. So many startup has come up. We started doing one thing with the small objective to make our own campus self-sufficient. We never thought of to make something in biogas and startup. But we realized, oh yes, there is a potential. Many people are asking us. We don't want to manufacture composter. But we realize, yes, there is a demand. And then one of my students said, sir, I want to start it. Good. So that's how these are like all startup, all entrepreneurship, what has happened around this concept, they are a byproduct. What I focused on education of my student. So that's the very important. Yeah. Yes.
Thank you very much. Very.
Oh, okay. The mic was just not on. I have a question. Did you, I don't know how the climate is there. Did you need to like modify anything to the houses where the people live, like insulation or ventilation?
Yeah. So we work like, I have not mentioned about housing, but at Vijnana Ashram, we work on the housing, low cost housing, a lot basically on that. We do different type of ventilators we use, like a turbo ventilators. Then we have basically a two-way roof so that there is a heat insulation. Because temperature during the summer goes up to 40, 45 degrees Celsius during the month of May. So it was very hot. So we have different ventilators tried on the campus. So the turbo ventilator and the we have a two kind of a there is an air gap in between two roofs. So that we use as an insulation. So in fact, in Vijnana Ashram, if you come, all buildings are made by my students. And each building is different. And each is designed by them, constructed by them. So we try to adopt, experiment different designs, different type of bonds. So in fact, one of the activity we give is to take a temperature sensor, and when the summer is there, check which one is most effective. So that is one of the educational activities we conduct. Yeah. Yes. Yeah.
Thank you. Very impressive once again. And I would like to ask a more personal question. Have you faced a specific challenge and how have you overcome it?
Yeah. So challenge means if you go to my website, our blog, you will find there are many incomplete projects. There is a lot of incomplete documentation is there. So that's the challenge. So what I told you, like, these are the good projects which we are able to achieve something, share with you. In the stack thing, the global and the things, like we conducted a workshop on solar yesterday. Like we had a design for solar dryers, we can share with you. We have a design for filters, we can share with you. We are sharing composting techniques. I have a workshop on Thursday. So these are things we are able to achieve something. But there are many things which are in pipelines. We are struggling on it. So in fact, yesterday I was telling you many wish list. So that is the challenge. Like the pace at which we want to do it, again, it's frustrating. Like so that is the problems, yeah. And the students who want to come in a village, see, you need to, when you want to do a project for the villagers, you need to give some soaking time to talk to the people, having that empathy, understanding their problem. But many times, the good student don't want to come, work in the village, talk to the community. So that's the challenge. So still we are able to get few good students and we are able to do this much. But that number of students, the problems are many. So there are so many opportunities are there. So there, sometimes we get frustrated, but sometimes when we get some kind of a good feedback, we become happy. Yeah.
My name is Adam. I teach at a business school, and I would like to ask more questions after. Can you still hear me?
Yes.
Online audience, can you hear me now? My name is Adam. I teach at a business school in Boston, and I would love to continue a conversation with you afterwards because I write about people like you. My question is more broad. Ashrams, do you know roughly how many ashrams exist? Is there a network? Do you guys share? Do you have a conference like this every year with other ashrams? Because I visited a great one many years ago, and I'm so curious if you guys coordinate.
Yeah, so basically this ashram is slightly different. Ashram symbol is basically where student and teachers stay together and learn from each other. So, but normally the people take in the sense of spiritual kind of a thing. So where you basically learn some like scriptures and follow some kind of meditation practices. So they also call them as a ashram. But this is a Vigyan ashram. Vigyan in my local language means science. So here basically a guru is like a teacher and students stay together. Both are a learner, both are learning from each other and they are learning about science. And for us, science is like a religion and the science is like a search of nature. So this ashram is for that. Ashram also symbolizes a simple living. So there is no hierarchy. Everybody is at equal. So like there is no as such a difference between me and my student other than like I'm learning something different and he's learning something different. I knew for more thing, he knows few more things than me. That's all.
Yeah. Hi. Very inspiring, Mr. Kulkarni. I wanted to ask. I mean, I was because it's already you've presented so many sides of it. Are there any next steps? Like I was curious that you said that it does go to 40, 45 degrees Celsius. So what about air conditioning or heating, cooling? Then, I mean, I also see a charkha. So are you also thinking about clothing? And lastly, I mean, I'll ask another question and then you can answer together. Is, I mean, I don't know if I can ask, how do you financially sustain all these activities? Okay.
First thing about the charkha thing, see, Vigyan, the Pabal is not a cotton growing region. So though we follow up Gandhiji, we are not a blind follower. So I don't have a charkha. It only symbolizes the technology which was available at his time. So whatever technology is available at my time, I'm using it. Tomorrow, maybe technology will change, something new will come. So that's the only thing. Your first question, the temperature and other kind of thing. See, we believe on, everybody should get a comfortable life. So that's what we believe. In Vigyan Ashram, we don't have a fan, a ceiling fan, until 2017. Not a single fan in any house. So during summer, if it is hot, we used to go out and sleep on the terrace and in open. So that was what we were following. When we started all these things to self-sufficiency, energy, solar, everything, and we found, okay, our energy bill is reducing, and almost now it become a zero. In fact, the company has to they need to pay us more than 2 lakhs rupees, almost like a $7,000-8,000 credit we have. So we started, okay, we said, no, we will put the fan, because luxury is our right, but it's not only for me. If everybody else get it, we want it. So we started generating, then we started consuming also. Of course, so far we have not gone on air conditioning because we have not studied it. It's a effect and various things. But yes, as he was asking about ventilation, the roof, so definitely we work on that. The material for construction, yes, we are very cautious for that in selecting material for our construction. So that we do. Still, so far, we don't have any air conditioning. Only we have a tissue culture lab, a bio lab. There we have a air conditioning because that system requires it. So that's all. Yeah. Good. Yes, at present, there are various income sources for Vigyan Ashram. Financially, I will say we are self-sufficient up to 40%, not more than 40%. I will put it another way. The direct cost of consumables, we are able to recover. But cost of development, purchasing of the new tools, especially like these computers and the 3D printers, and if they become obsolete, we need to replace it. That cost, we are not able to generate ourselves. So we need to go for the philanthropic, for the capital cost. The direct cost on the student for their food, for their lodging, for their materials for practical, all this experimentation, we are able to recover from the fees. So 60% still we have to go for the philanthropy. Again, this is again an ashram. So in an ashram, the philosophy is the knowledge is free. The knowledge is free, and so the society has to pay for the teacher. It's in traditionally. So in the past, the teacher was to basically given in the form of various offerings by the community. So Vigyan Ashram, at least the cost of the teachers, we don't directly load onto our students. So first, this 60% comprises of all these things. So yes, we are still depend on the community, and I'm not sure because if I load all the cost on my student, then they may not come to me. The community for which I am then my cost become unaffordable for them. So price tag depends on what is the affordability of my students. It's not of how much I am spending. How much they can afford, I just have to see it. Because if they don't come, I will not able to do many things. So yes, the community has to support us. If they want, we are doing good work. And thankfully, from last 40 years, Vigyan Ashram is working. This year is our 40 year, and the community is supporting us. Yeah.
Hello. I'm joining the others to thank you very much for that really inspiring presentation. I was wondering if you had any inputs to share regarding the place of female in that project. And you said earlier that it was one of the struggle was to attract the good student. Is the fact that it is a special place actually a way to attract women that would have another strategy to develop and learn?
So yeah, so till 2015, we don't have a separate ladies hostel. So when we realize, okay, the girls are not coming to Vigyan Ashram, with the help of one of philanthropic, our friend, we constructed a hostel, separate hostel for the girls. So 16 girls, the hostel is, so there are minimum number of girls are 16 on the campus. Because the hostels is there. If they are not there, the room will remain vacant, but we will not take anyone. So that is like a reservation. So we started getting the girls. What happened, this many engineering colleges and agriculture colleges now started giving emphasis on the internship and doing a field works and projects. The girls basically found Vigyan Ashram more attractive because it's a place, safe, secure, and another thing, basically, everything is on the campus, the hostel, and instead of sending them somewhere in the industry, the parent also feel it better to send to Vigyan Ashram. So in fact, we have more girls coming in than our hostel capacity. So hopefully maybe next year I need to make a proposal for having another hostel for the girls. So yes, but 16 out of, I will say 70. So that's the percentage at present for the girls. Yeah, by the way, another thing, there are professors in Indian Institute of Technology, Mumbai. So there is a engineering college. So there are the few engineering college professors are there. They said if the girl student is there, we will take the cost. If she is not able to pay for the fees, we will pay it. So we don't face like, we are welcoming for the girls. Yes, somebody else? Yeah.
Yeah, I was wondering, what do you think is the charm of moving back to a village or the advantages?
What are?
The charm of living in a village. What would you say is like
Yeah.
the charm of that and the advantages?
Yes, yes. There are many perks. If you want to join Vegan Ashram, like I was telling them, you don't have to travel time for the for place of your work. In fact, you get a very better quality of life. You get time for, let's say like in Vegan Ashram in the evening, we do meditation regularly. In the evening from 7 to 8, 7 to 7:45, we have a common kind of a discussion, sports, everything. So we have like a small community, 100 people. We do sports, we sing songs. From 7:45 to 8, we do meditation. In the morning, 7 o'clock, we go for a jogging together. We eat together, we food together, we do celebrate different festivals. And we don't have to basically go into the pollution, nothing we have to do. When there was a lockdown, we were the most happy people. See, and nothing was going out from the village, from even our own campus. So we were sufficient in terms of eggs, milk. So we used to make like a various kind of Indian sweets, if you have tried, made out of milk. So all these things we were making, and we were enjoying during the COVID. So many perks. Yeah. Okay. Yeah.
Hi, Dr. Yogesh. Thank you for the talk. It was really good. I wanted to ask, is there any way Vignan Ashram is actually generating economic opportunities for women around the village? Not only the students who are coming in, but women around the village or like nearby villages?
Yeah. Yes, there are startup, like one of my students recently started a startup called as Serve Hrudaya. So she make the authentic Indian food products, like a different kind of traditional recipes. So she is, by the way, she is a chemical BTech in chemical engineering from the very reputed college, very like prestigious like IITs in Mumbai. She wanted to work with the food. She got fascinated, and she basically taking the different recipes from different part of the countries, making it very kind of a systematic way, very good standard, and she's doing it very successfully from last 2 years. So there are many shops. She's exporting also. Like many prasad in US, in the temples they offer the prasadam once you go to the temple. So many times the laddus she's exports in some of the temples. So like this, it's happening. So yes, there are startups. We encourage our students to take the technology and to start their enterprises. Yeah. Okay. So thank you. So these are like, you have my contact IDs.
Yep. Thank you so much, Mr. Yogesh, and so inspiring. Yeah, one more thing I wanted to mention was maybe Thomas and Kate were not here, but I think they're actually fulfilling the full Fab City full stack. Yeah, bootcamp. All the 7 layers have been checkmarked, and I'd like to tell all of the Fab Labs in Bhutan to interact with him also, because if you see most of the pressing problems that happen in Bhutan are similar to what you see. So maybe Mr. Yogesh, if you could answer one of my question, which would be, how do you think Bhutan can take your model, and where do you think it'll bring the most impact with a lot of projects that you've done?
See, whatever we do, basically we can you can see it. Like yesterday, I was interacting with some of the Bhutanese friend. They were in my workshop on solar dryer. They asked me, we don't have a sun, what to do? I said, yes, the design is the same. Only you need to go for the biomass based, like maybe wood fire kind of a dryer. And so I told him okay, this part you can just replace and you can localize it. The further part, the next part is ready. So you need to just maybe adopt it, little bit modify it as per the local condition, and you are a Fab Lab, so we are open to share with you. In fact, you are not too far. Like I came with my 8 of my colleagues by road. Yeah, so you are that close.
Thank you, Mr. Yogesh. So if you want help in terms of innovation, sustainability, community building, please reach out to him. I'll just have a look at the time. We still have 5 minutes to the next session. Anyway, I'd like to call Mr. Julian Hammer if he's around. Okay, we have him here. So meanwhile, while he sets up his system, where's Fran? Fran is going to help him.
I think both of us.
May I have your attention, please? For those who are standing, please be seated. Please be seated. Yep. If you want to take the discussion outside, please feel free to use the sideline outside the main event. Okay, so we'll start with the final session. And just to remind you, after this session, we are screening a movie. It's called Yuck in the Classroom, and it was an Oscar-nominated movie for the best foreign film as well. So it just came second after Drive My Car, that was last year, which is a Japanese movie. So please stay back, relax, enjoy the movie. But before that, the final session, sorry, we have Julian and Daniela, who from Germany, and they're going to talk about bootstrapping a 3,000 square meter makerspace with help with volunteers. So this approach also has community, sustainability, innovation involved with them. So please give a big hand for the both of them. Thank you. Over to you, Daniela and Julian.
Hi, is this working? Cool. I really like the cricket background. Thank you, guys. I know you organized this. Okay, so hello, friends here in the Dragon Hall, and also my German friends. I know our German friends. I know they're watching remote, so thank you and hello. Yes. So here we are, and what we want to talk about is community building. This was a very dynamic presentation, actually. We talked to a lot of you during the last 2 days, and we added so many more slides to this presentation because we got inspired about your ideas and what you want to know about us. So here we will present some aspects which we identified as necessary to foster a vibrant, or I heard this is a buzzword here, a resilient community of individuals that are willing to actively contribute to the development of our space. You can feel free to ask questions at any time during our talk. Will you guys help us with the microphones, or how does this work? If somebody wants to ask a question, just raise your hands. We can just clarify whatever is not clear for you at that moment. Yes, but first, some background about us and the location of our space. I would like to introduce Julian. He is a computer scientist. He finished his PhD. So from now on, you can call him Dr. Hammer. He has over 20 years of experience in volunteering, and he's our full-time setup manager. So he's our paid employee.
Thank you, Daniela. And this is Daniela. She is usually called Shumi, and she's a PhD student also in computer science and has a lot of experience in volunteering as well. And she's a volunteer board member of the nonprofit association, which we have as a basis for our space, which Daniela will present now.
Yes, so our space is called Ta. This means in our southern German dialect, together. And the letters mean Zentrum für Austausch und Machen. You wanted to hear some German. Oh, thank you. This translated to English means Center for Sharing and Making. But in German, this is the word Tam is a little word game that means in our southern dialect together. And we recently found out that in the primary Bhutanese language, Tsonga, this means also bridge, which is a very fitting symbol for actually what we are trying to achieve. What is important to mention is that we did not yet completely open our space. We are still building. We will have some more information about this soon. So as we were talking to people here, everybody was asking, where is Erlangen? We have never heard about this city. So just to make it clear for you, here is Earth. This is where we all are now. More exactly here in Thimphu. And if you go across the globe, then you land somewhere in Erlangen. Just for reference, down here is Africa. Can you help me, Julian, please? Point to Africa, point to Europe. Erlangen is in Germany, which is in Europe. Here's another zoom in. Here's Germany, in the middle of Europe. And our city is in the southern part of Germany. It's called Bavaria, this region. And they have a very nice dialect. It's important to mention that our city is a university city. We have about 116,000 students. No, sorry, 116,000 city population, and 30,000 of them are students, and 35,000 of them are Siemens employees. So Erlangen is the birth city of Siemens. I'm sure you heard about them. and they have their development there for medical equipment. So this gives us somewhat an advantage for our, or at least this is how our community is mostly, the higher percentage of our community is formed of academics and also students. Also because we have Siemens there, has a lot of funds available to support us. And I mentioned that the city supports us. That means that they provide the funding for our space. Here's another aerial picture of our space. As you can see, it's really huge. It is located in the center of our city. It's about 100 meters away from our pedestrian area. This is where the main shopping street is, so usually where people go out and walk around. But the northern part is actually the historic center of our city. And what happened there also before the pandemic was that a lot of stores and places were closing down. This was also severely increased by the pandemic. But this actually was our luck because first of all, the city wanted to find other attractions in the center of the city, but one very large kitchen and hardware store decided to close down. So the city purchased this building that you can see here for us, and they entrusted us with building their community center, which includes a makerspace, but also it should be like a cultural educational center for all the people in Erlangen, open for everybody. So we are so big that we even named our buildings according to cardinal directions. And it's actually not a connected building, it's a complex of buildings that was in the beginning, it started in the 17th century, end of the 17th century with the south part here in the front. The north part was sometimes in the 70s, 1970. And the most recent part is actually here, where they just built over an inner yard that they had. Now it is like inside for us. This is actually, it's a big space. We were talking about 3,000 square meters, but it's also a historic monument. Like the whole ensemble of buildings is a historic monument, which implies some restrictions on the renovations possible. As I mentioned before, we are now in the process of renovating this place. We are making it in accordance to the German fire regulations for the amount of people that will come and visit us. But also we want to make it accessible for everybody, so also people with disabilities, for instance. Here you see the front of the south part, and what we are planning is to build on the upper level some residencies. These used to be old apartments before. We want to keep them as apartments, and here we want to invite makers from all over the world, maybe you someday, that will teach us their skill. So in the future, let us know if you want to teach us something. On the first floor, we are planning a place where people can make their projects. All would be open, so no closed spaces, and also co-working spaces. On the ground floor, this is the place where we welcome everybody. Here we have our window front, and we will have exhibitions, maybe a cafe, and we will hold workshops there. This is basically where people come from the city center. This is where they walk by. This is where they see us. This is our main focal point. Yes.
And what's also important, because Daniela already mentioned that we're not yet open. The only space we can use at the moment is down here. So it's 10 to 20% of the whole building we are only allowed to use before, until we have completed the renovations. And these renovations, to a large part, we do with volunteers. So that's what we'll talk about.
Yes, this is the backside of our space. And this is the plan that we have for it. So on the, I don't know, third, fourth row, however you want to see it, we will have the Colors and Media Lab. The Color Lab is actually the most exciting part. That was the suggestion of our artist community. They just wanted a place where they could just throw colors on the wall. And we said, this sounds like a very awesome idea. We will give you this. So we have architects that were already like planning the labs and everything, and they came and said, we want to make a big mess. And you said, sure, we welcome you. This is what we're here for. We will have textile and a print lab. And actually our main attraction, we hope, will be the prototyping and electronics. Well, we have the laser cutters, 3D printers, and so on. I think this is what the most people will come for. But we will also have a very large wood workshop on the bottom level, a metal workshop with all the machines included, and also a biolab, for which we already have the guys that will manage this lab. But enough about the buildings, let's talk about the people. They are very important because we are very grateful to have many people that support us. So our structure is like this. We have a board of 3. I am part of the board together with Mike and our treasurer. And then we have the 4 advisory council. The 7 of us are elected by the members of our association, and we represent them. Then we have Julian, which is an employee, and Jochen, an architect, which are the only 2 employees that we have in our makerspace. And then we have some supporting members, which always help us when we meet to make decisions or coordinate certain groups. For instance, a shout out to our lawyer, Balthazar. In his free time, he gives us legal advice, and we appreciate him a lot. Every makerspace needs a Balthazar. That's what we always say. I want to emphasize here the diversity of our group. As you can see, we have all ages and all backgrounds, and we are a great team, and we have a lot of respect for each other, and we work very well together. Now I'll give over to Julian.
Yes, when starting such a place, of course you need a vision. And so building a vision comes first when you talk about such a project, even before you have a budget or the actual place to be in. So when doing so, it was always important to us to be in touch with our community. So for some, we have been working towards this project for more than 10 years. What may seem like as like a linear progress toward this goal, we took many detours, but all of these detours somehow shaped what we are now. It started in 2011 with the 10-day temporary Museum of Creativity, which was located in an abandoned storefront in the city center. This is what it looked like. The project name was Ich kann, which means I can. And this sparked the idea for me to start a permanent student-run Fab Lab at the university. So that became the FAU Fab Lab. FAU is the name of our local university. And here, since 2011, it's permanently run by students in their free time. So there's 0 staff involved, but that gave us a lot of experience in setting up a makerspace, operating it on a day-to-day business, and also how to work with a large team of volunteers and how to self-organize and what to pay attention to in the general structure of an organization. So the structure Shumi told you about, this did not exist in the FAU Fab Lab. It was all grassroots, only uniform decisions, and so we learned from that and based our new structure on our experience there. And during this time, we also had the possibility to go to FAB conferences. So this, for example, was FAB10 in Barcelona. And we visited makerspaces all over the world. And here we exchanged ideas and sharpened our vision, which now we implement around some. But before we could actually implement it, we had to convince politicians, administration to give us this huge building and also the budgets to operate it. So with the vision in mind, we set out to promote it, and with the help of the city's cultural department, organized a temporary event which would showcase our concept of a makerspace for everyone to the city counselors, to administration, but also to newspapers and the general public. And all of this took place in a, again, abandoned store, which was selling carpets originally. And as a concluding event of this event in this former carpet store, we had a co-creation workshop with administration and politics on how to make this carpet fly. And that kind of sparked the whole process of getting support from the city, and then the founding of our nonprofit association, which fell right into the Corona lockdown period. So this is the founding meeting, which was completely virtual, but nonetheless more than 80 founding members showed up, and now we are more than 300 members in our association. And since this was 2 years ago or 2.5 years ago, we are quite young as an association, but nonetheless we are being entrusted a lot of responsibility from the city. And that was only possible with the 10 years of work and building of trust between one another. And to reach more makers and artists throughout the city, we used the Corona time because a lot of events were canceled. So we got the option to hang our posters in many places in the city because they were not used for concerts or other things. And we tried to highlight the diversity and openness, and also to promote the idea that every one of us can be a maker. And that eventually then led to the handover of the keys in 2021. We got the keys to the building and now have a lease for 10 years. But it's a special kind of lease where we actually are kind of owners for 10 years. So we can do all the construction work on our own, which is very important because the city doesn't have administrative capacities to quickly start a project like we are doing. So this is what some inside of the building looked like when we got in. So this is where our carpentry workshop or woodworking workshop is going to be. It's hard to imagine that that's possible there because the former owner left pretty, well, not everything, but a lot. So to a large extent, it was still equipped with the hardware from the hardware store, which sometimes is useful. But in other times, it's also in the way. And this, what you see here, back here, this here and there, it's 20 tons of raw bare metal, which we get to keep, but we also have to move because in the carpentry workshop, we're not going to use it. And we soon realized that clearing out and renovating was going to be a humongous task ahead of us. So 1 year ago, we made a survey with our members, with our community, and we asked them how much effort they would be willing to, or how much time they would be willing to put into this project for the just the renovation tasks. And we were really surprised, and well, very positively surprised, that they said up to 2 times a week. Not all, but some of them are willing to come by and 2 times a week break down walls, paint something, move boxes, whatever you can think of that you have to do. And this became the idea of Zusammenräumen, again, a game of words. So it means cleaning up together. And we set it up such that every Tuesday, so actually tonight in 4 hours, it'll start again. Every Tuesday and every Saturday, we have this Zusammenräumen going on. And people can just show up. So it's really easy to join in. You don't need to be a member. You don't need to know anything because we have clear tasks that we will delegate, and we are always working in teams. So it's also a social event. And we also have dinner included. So it actually turned out that we find volunteers that maybe don't want to paint, but they want to cook for everybody. And that has become a very big part of this whole concept, that the social aspect and sitting together and also eating together is part of Zusammenräumen. And then slowly we built a team of coordinators. So in the beginning, I had to be there every Tuesday, every Saturday. And actually it was a big load on my back, but now I'm in Bhutan, and still it will be going on in Erlangen in 4 hours. So that's a great progress. And these coordinators all do it voluntarily. So we have a small group of people that are very responsible and have a good overview of what needs to be done. And then we have like shared to-do lists, and from that we have many tasks. So here we were counting metal bars and things. So we didn't even know we had 20 tons until we counted all of that and measured them. Breaking down walls, cleaning floors, making some part of a building pitch and safe. And to give a better idea, this was the hardware store section, how it looked when we entered. When we kept clearing out the shelves, and of course we want to find the things again. So we built our own inventory system. So we take pictures of the things, we count them, we put them in boxes, we have a label on the box so we can find them again. And then eventually we took down the shelves, and it turned out to be more than 30 pallets full of shelf pieces. Luckily, there was an aid organization which was willing to take all of them. And now they're equipping refugee homes with these shelves. Otherwise, they would have to buy new ones. And then eventually the room was almost clear. And then we started on the electricity, because it turns out a retail store has very little plugs. And if you want to have a Fab Lab in there, then you need actually quite a lot of power outlets, which our electrician told us, if you're going to install one new power outlet, we have to redo the whole electrical grid, because it's all from the 70s to comply with the new safety features. And so we ended up working together with a professional electrician here on the bottom left, Lucas. He's helping us plan the electrical system, how we need it for our workspace. And then we have certain weeks, or in some cases, like concentrated actions, where we pull in the volunteers, and there every day we work on installing the electricity. And he's around checking that we do, telling us how to do it, checking that we do it right. And then in the end, he signs off and also takes responsibility, and his insurance will take over if anything goes wrong. So now we have light in there, and we can soon move in the laser cutter and other equipment. And the room you saw before, the former metal storage area, which we also had to disassemble very slowly, and then eventually move the big metal pieces. Now it was almost cleared out. So here again, we are working on the electricity, but also painting the walls. Here we have the additional obstacle. Everything is 4.5 meters high, which puts an extra challenge there. But within 1 month, we finished all the electricity in there. And there was already an artist's project for an international theater festival in this room. And then, as mentioned, dinner is included to support the socializing and sharing of thoughts, making personal connections, and usually volunteers cook for the cleanup crew, and underpinning the community aspects even more. And when we always try to encourage everyone to have fun while contributing, so of course it's not really about the work, it's about building community. And on the side, we're also getting the work done. So things like these are really important to always include in there. And it's not about being efficient, it's about having a good connection between the people and the space, because the people are putting so much effort into the space, they're having a big connection to it as well.
Yes, this is why we built this place. We build it for the people. That's our main goal. So that's why we want them to be happy, of course. So let's talk some more about our community. One thing that we have, that we learned over time, actually from the University Fab Lab, is that it's important to give our members a lot of trust. That means that we offer them, with a very low threshold, 24/7 access to the building and everything, all the machines, everything that we have. We currently have about 100 members that have this access. We never had any problems with this. As mentioned before, we have about 300 members, so 1/3 has complete access to all of our spaces and machines. And because we were asked about this, I want just to mention it. We have developed, our members have developed a system. The question was, 100 members, where do you get 100 keys? No, we don't have keys. Hey. Oh, thanks. Okay. We don't have 100 keys. We have developed a system. We have locks, very expensive locks. But you can open these doors that have these locks using your mobile browser when you are connected to our Wi-Fi. If you have more questions about this, come to us later. We can tell you about it. All right. The next thing we have to encourage our community is a kitchen. So I have to tell you a secret, guys. I really hate painting walls or tearing down these shelves. So I actually said, I want to give something back to the people that are helping us. Let's cook some food. So mark my words, food brings people together, and it has to be good food, okay? So I always try to cook the best I can and offer back to the guys that are investing so much of their time. And I think this is the moment where they actually get to come together and talk to each other. And it's important that they have this, that we have these moments. And also, it's not only me. We found many other volunteers that offered to come and cook. And actually, every time people get together, all the teams that have formed inside our space, there's always some food being cooked there, like cakes, or they make ice cream, or there's always something going on around the kitchen. So this is a very important focal point. One other important thing is the appearance of our space. We value this place. We want it to be attractive for everybody, and we want it to look inclusive for everybody. We want to go beyond technical accessibility, and we want to take into consideration the perceived barrier of entering a new place. We want our space, we want it to be available for everybody and not feel like it only belongs to one group. So we are very careful about this and how it looks. One important day for our community is Friday. We want to offer a sneak peek of what is to come in our space. So we thought we could open in Friday evening for everybody. Like we invite everybody to come inside. It turned out to be a great success. There are over 50 people. Like every time I go there on Friday, I'm amazed of how many people are already there. Like our members, new curious people that just want to see what's going on, people with their kids, some grown-up kids, as you can see here, our artists that meet together and they're working on their projects, and so many more people that just want to see what's going on. This is how it looks from the outside. As you can see, we try to make it very attractive and inviting. And of course, you see these bikes here. This is the main transportation in our city. You get everywhere, you get faster with a bike, not with a car. So we're also very environmentally friendly. This is an image of how it used to look inside, because now this is a construction site. This was a sneak peek of our prototype lab. So we had like a little laser cutter there, some 3D printers, a lot of tools in the back. We tried to show people that were coming inside what they could expect when we will actually open our space. We plan a lot more and bigger machines, so many more square meters. And again, I have to mention the food. It's very important to offer opportunities for people to get together and get to know each other. We organized a grill party here, but I think you can see in the background some people that decided, oh, well, we have some time now, let's just do some more work. So they were just like cleaning the windows there in the background. That was really awesome to see. Yes, I give back to Julian.
So because we have the community, but we also have our so-called crew, which is the elected representatives of the members, and also some supporting people like us employees. Transparency is very important within such a group, because we don't want, in decisions, we want to take along the community and them not feeling abandoned there. So something we employed, here you see a crew meeting. We're still keeping a lot of that virtual there to make it easier. And we have this so-called flashbulb newsletter where we are reporting on from our bi-weekly board meetings. So we take the minutes, we make it in a little longer form to explain the discussions that were going on. And even if we don't take any decisions but have been discussing a topic and it's controversial, we put it into that newsletter and we send it out. So when members have an opinion, they can come to us, they can discuss it with us in person and then contribute to that. And this has gotten very good responses, not even within the members, even it's being sometimes forwarded to politicians and administration people. They see this transparency and all the work that's going on behind the scenes that people would usually not notice. And this has been a very good decision improvement to the transparency. In the beginning, we didn't have that, and then we got some feedback and worked on that and came up with this so-called flashbulb newsletter. But then we also have regular all-member board meetings. This is not the formal all-hands meeting, which we have once a year as required by associations in Germany. But this is like, we have a topic that we want to discuss, and then all the people that are interested in this topic, we come together. We have it announced a couple of weeks beforehand, and everybody gets heard. That's very important on these meetings. So everybody gets to say their opinion, and if they don't want to say anything, they have to say that. So nobody can just quiet out in the back and then later say, I wasn't heard. And that's makes a big difference. And it has proven that that before discussions were going a little bit more controversial, here you quickly see the overall, what's the overall feeling towards a certain topic. And then we have workshops which we call some for everyone or some for all. And they're also on specific topics. We're prototyping. And here, this one was from one, how do we design a SUM which is suitable for children and their parents? So we invited children and their parents to come and tell us their ideas, how they would imagine the space. And then we built these small models. And from that, we're taking out ideas and then incorporating it into the overall design of the space.
Yes, one advantage that we had in Erlangen is that we already had some existing communities. I don't know how many of you have heard about the Chaos Computer Club, the hacker community in Germany. They have a group in most cities in Germany, most large cities, and we were very lucky to have a lot of their members join us. But we also had the Artists Collective of Erlangen that decided to join us, and they contribute a lot to our space. Also, we have a repair cafe for people that don't know what this is. It is a meeting where we have a group. In our particular case, we have a group which is partly retired seniors, professionals, which help you repair your appliances. So it works like this, that people bring their stuff that is broken and they are being helped to repair them and keep them instead of throwing them away. And this is actually very nice because it attracts a lot of people that understand that they can use these tools that we offer there to actually help themselves.
And what's important about that, so these groups have been existing beforehand, but they were all waiting to find such a place and to jump in. And so we collaborate with them. So for example, the Repair Cafe people, they were at a different place, but they had to always pack all of their tools into boxes, put them aside, and it was so much effort for them to set up and have these events. And now in our place, they find all the tools readily available, and so it benefits the two of both SUM and Repair Cafe. And now when we have something broken that we don't have the time to fix, we can give it to them, and they have this event going on once a month, and it's beneficial on both sides.
We also have a group of screen printers. You have seen these guys in the gazebo. We have some of them at our place too, so you can make some t-shirts there too. Among other groups, we have a Linux user group that also joined us, shameless self-advertising, I have an escape room building group that has also joined our space, and we have a room there. Yes, you're all looking at this laser cat, being mesmerized by it. That was a party that we organized during a hacker conference that we had in winter. So we thought it's representative. Again, the computer nerds, I'm also part of them, so I have to advertise them. We had them refurbish some vintage computers, which we were presenting during an event that we had in our space for nostalgic adults, but also many kids enjoyed very much playing those old retro games. And also, we have a lot of know-how and equipment from our members. Here is an example of splicing fiber. I don't know how many of you know about this. So we are putting fiber through our space, but this process is actually very costly. The expertise to do this is very costly, but also the equipment that you need. You see this machine here, this costs a lot of money. But we had this from people in our space, and they helped us with this. So thank you very much for that. Applause, you guys, if you see us. I want to mention also our artist community. Every 6 weeks, they make a challenge to decorate our window, the one that points toward the streets. That where the people walk by and see us and then come inside, and they are attracted by what they see there. And somehow out of this artist group, also a textile group developed, which also brings a lot of people that want to repair their things. So we're also very grateful for them. Here's an example of how they were decorating our windows for Christmas. Another group that was already existing was a group of board game players, but also board game developers. So they were inventing their own games. Now they meet and test these games, but also they were joined by people that are conserving historic games. For instance, a shout out to Irina. You see her there. She is an Ukrainian refugee that joined our space, and she's rebuilding old Viking games, which she plays together with our members.
So to conclude and to recapitulate on the lessons learned that the lessons that we learned to foster a lively community is, well, first of all, you need to present a vision. You need to present it to your community, but also you need to keep updating and including ideas from your community. So you need to be flexible there and always keep up with what the community needs are. Then you can distribute workload, and of course that's one of the things that a community brings, that you have a lot more people and shoulders to put your work on, but you need to do that without pressure, because volunteers are not employees. You cannot expect them to commit to full days working or to have the reliability of someone you're actually paying. If they voluntarily commit to that, that's totally possible and doable, and we have some people that do pretty much full-time work, but it has to be them wanting to do that. Do not pressure them into that. That will kill your community. Then we found that a low entry barrier is very important, because some people just want to show up. They don't want to have anything like extra effort around it, signing up to things and so on. So just showing up should already be appreciated and should be a way to contribute to the space. And then the social aspects are a key motivator for many people, actually for most that we have seen. And with that, you also need to communicate your internal workings, and by integrating existing communities, you can tap into what is already available in your town, in your location, and these existing communities should also profit from it. So it's not about pulling their people away, but trying to integrate them in a win-win kind of scenario into your space. And then we always, with these for all workshops, we try to regularly reevaluate our inclusivity so that we are still open to everybody and attractive to be joined by many people. And here, as a symbolic representation of all the hands carrying the TSAM project, an artist created, he's here in the center, this large format cyanotype print, which was exposed by sunlight. And now it hangs outside on our building, and it shows all the hands of the TSAM community. Of course, we have many more hands, but it's a symbol for what is carrying TSAM. Yes, that's our talk, and now we would like to open up for questions.
What we didn't include in this talk was, if you're interested to talk about with us later, is also like a bit of expertise of how to collaborate with your city, because that is one of our, I think, one of the most important things, the support that the city offers us for our space, for which we are actually grateful that they put so much trust in us. So if you want to talk about that, you can also come and talk to us. I have a question for the public. Who knows what this how did you call? Sorry, I say
cyanotype printing is.
Does anybody know what this is?
Any guesses?
Okay.
Oh, there's someone at the back. Yes.
It's you know these old blueprints. Why they're called blueprints? Because it's a print using blue color, and you in this case it was a fabric. It was covered in a chemical, a non-toxic chemical. You can actually have this this workshop with kids as well. And when you expose it just with sunlight, and wherever the sunlight falls, when you put it in water, it turns blue. And what wasn't exposed to sunlight or UV light, no, UV or infrared? I think UV. What wasn't exposed to UV light will be just washed out by water. And with that, you can make very large prints just by sunlight.
Okay. Oh, thank you. So the crickets left, the mosquitoes came. It's time for questions.
Okay, any one of you, do you have any questions? Okay.
Love it. Congratulations.
Thank you.
And I really hope to get to visit one day.
Please, you are all welcome. Just let us know. As we said, we are trying to also make it possible for people to visit us. And by the time, actually, until you're finished, we will find a way to host you. You don't need to stay in our space. We will find a way. Don't worry.
Thank you. My name's Andrew, and I'm here with the Internet of Production. But one of my hobbies is to try and set up a makerspace in my own town. And the council has given me a space, an old building. So I'll be doing some of the things that you've shown some videos of here. You talked about external communities that you engaged with, like the Linux group and the hacker group and so on. One of the things that I'm going to have to do is make money from people using the space. And because I'm going to have to pay rent and probably going to have to pay a profit type thing to the council and blah, blah, blah. Near me, there's a load of movie studios. So there's lots of like people making props for the movies. There's also a lot of engineering. I live near Heathrow Airport, so there's a lot of people trying to make spare parts and things for aeroplanes and bizarre things like that. What kind of communities could you imagine you'd engage with? Because my bias is that if you're engaging with like Linux user groups or hacker communities, you're not engaging with them to make money.
Maybe we have some expertise from visiting other makerspaces that are making a profit, more or less. And I think some of them, like a success recipe, is actually using your lab as innovation incubator for startups, for instance, that you invite companies to build prototypes and then ask them for rent. Or, for instance, the co-working space. This could also be something you rent. A restaurant could also bring some money. Any more ideas?
So some almost professional makers are also willing to put money in. So it's always a balance about being open to the general public, which typically does not have the money or wouldn't be willing because it's not their like main hobby that they do. school children also would have that issue. So that's the more professional makers, you could offer them some additional services like earlier access hours or things like that. And then we're also looking at third-party funding. So we're looking into project funding, for example, for the school children. Right now, we apply to a grant to have most of the elementary school children once come through our labs in the next 3 years. But we don't know if it's going through yet, but that would fund the people and also some of the space in that regard. But we must say, this funding from the city, we are completely relying on it. Well, okay, not completely. We will have some revenue streams coming in, but with our ambition to be completely open, this space will not carry itself financially like taking everything into account.
Another idea just I need to mention. So we also have, at least in the university lab, we had this model that if people use the so right now we are offering the machines just for the price of the materials and a small amount just to have the machines like that we keep them. So basically it should be available for everybody if you do your own projects. But if you use the machines for a commercial project, so if you make profit out of it, you can have higher prices, which also would bring, but it's not a lot of money that you get from that.
Which we are actually required to do because we are non-profit, and otherwise we would be subsidizing indirectly commercial projects. So actually there's some financial tax laws that need to be taken into consideration.
Also come to Julian if you have questions about insurance. Like insuring like the space and the machines and the people that work there if something goes bad. This is what I mean. He doesn't try to sell you insurance.
Just a comment, building on this idea, we are helping a Fab Lab downtown Puebla, and making money from the Fab Lab, it takes to go out to the market and offer projects. And one good source of money that we have found are gifts. Some companies giving Children's Day gifts to older, and we design, specially design for that company, these gifts, or for Mother's Day, or Father's Day, or Teacher's Day, all these events that you could go with bigger companies. They don't care about spending thrice the cost of what we design. The important thing for them is that they have their logo and their stuff in a well-designed thing. But don't wait for clients to come to your Fab Lab, because that's not going to happen.
Yeah, I also heard about companies organizing team buildings in the workshops. I heard they pay a lot of money.
Thank you very much for your presentation. It was very energetic, and I really feel like your community is kind of living. And I have one question. Germany is known for great engineering, but also for great kind of restriction and laws and stuff like it. How do you manage the volunteering reconstructions with the German laws and these kind of things?
We have a lawyer.
No, that's
which is volunteering.
Okay, so we have to pan it out a little. So there's like this core construction work, which is making the whole space according to the fire code. Then accessibility for disabled, especially wheelchairs, and getting the sanitary units like toilets and so on renovated. All of that is completely financed through the city. So we can actually pay first an architect, but then also construction companies doing these different works. But that just gives us the option to use the whole space. Everything beyond that, like renovating or getting electrical outlets and so on, that is on the community to do. And in these things, except for electrical, are not so much a safety issue. So if you paint the wall with one or the other color, or if you do it wrong or right, doesn't really matter from the law's perspective. Regarding electrical, there we are working with a professional. So we have an electrician who does support, we plan the electrical system together. We have some people that have experience in it, but they're not certified, so they wouldn't be able to do that. And they're also not actively working in that field, so they don't have the right insurances and so on. So we have an electrician that we pay regularly, and this electrician then instructs our volunteers how to do it right, how to install cables, how to install plugs, and how to wire things. And then in the end, the electrician goes through everything and checks that it's all done according to the regulations, and then he signs off on that. And therefore, we still pay some money. Of course, the material always costs money, but also his work. And then we still save some money, and the community has a feel of belonging to that, what we've built. So it's kind of a middle ground regarding electricity. On the fire code stuff, there it's completely with the companies, and one on the classical renovating things and making things look nice, that's just on us.
Thank you. Any further questions?
And just an afterthought while the microphone travels. We actually have more than one, but the other one is doing our walls, right? How do you call this in English? We have more than one lawyer.
Yeah, we have a drywaller
Drywaller,
that is
yes.
also a lawyer, but
Yes.
yeah.
Yes.
Yeah, we have a team of lawyers, and one does drywalling and the other one does
That's a new model, no?
energy efficiency.
Lawyers for makerspaces, like, yeah. Amazing, Julian, Shimi. So much love, and amazing that you guys have done this. Just very curious about the relationship with the city council and the city model, and just wondering, apart from the funding, right, or I guess the space, and I'm kind of curious on how that works. Do they set with you guys any kind of targets, like impact targets with, how many people are meant to come through, or certain learning outcomes? Or is it more softer side where it's really from the cultural creativity aspect of revitalizing the city? And yeah, just maybe some experience on how you guys manage that.
Okay, so regarding the targets, right now it's on the softer side, but that is going to change. And that is something, so we have to start the place first, and then we will define targets once we have it all set up. So as you can imagine, construction work of that size in an old building, you don't even know how long it'll take. So setting targets right now for next year, we don't know specifically when we will be able to open next year. Right now, our plan is middle of the year, but well, you never know. Sometimes you open up a wall and there's something really nasty behind that. There's extra work to be done. So the targets are really on the cultural sides and bringing people within the city together. But then, of course, we can talk about how many people come to the space, how many school children will be part of workshops and so on. That we will define in future within the next 1 and 1.5 years. And that will also be very important to the city council. We have already had these discussions there, but we're not at the point yet. And they do look at both sides, yes. So we've been given a lot of trust, but of course now we need to deliver. And the whole project right now is set for 10 years. But doesn't mean at 10 years it ends, but it will be re-evaluated. And at that point, we need to show what we've done. And therefore, we need to set targets and then prove that we fulfill them. Now, the other part about the relation, so we have a very, so one of the advisory council members, which was regularly elected by all the members, but she's also head of a cultural department. And she made the whole project also possible. And she, of course, her boss is on the politics side, so she's on the administration side. Her boss is the link. She is the link between administration and politics. So that's how we also have the connection to the city. And if in future, when we re-elect the council, nobody from the city would be elected by the members, then the city gets one extra seat in the council, but without a vote. It's just like to get to know what's going on. This is actually a concept that we took from another cultural center, which is also in the city, which has a similar setup. So they also are organized as a non-profit association, which their setup in total is a little bit more complicated, but they have a cultural funding contract with the city, and then they have a person from the city which can sit in on the meetings and like has a say but doesn't have a vote.
Okay, any further questions? Yeah, I think we're good. And on the SuperFab Lab side, interestingly, I'll tell you my story. So whenever we do workshops, programs, we started with teachers, students in the lab. It didn't work. We couldn't sustain, but the happiness that you get, sharing the knowledge, building community around it is different. But we got all the revenue from big corporates, but you don't actually like doing the work, but you have to do it for the money, right? So I think there needs to be a balance between economic opportunity and how you work, engage with the community. Both of them are very important for sustaining your lab or your makerspace. Anyway, thank you so much. And maybe a question from my side. We work with the SuperFab Lab and we have like a hub and a spoke model. So the hub is the SuperFab Lab and the spoke would be all the Fab Labs around the country. And we also, because our network is just 1 year old, we're also trying to build a local Bhutanese community revolving around the lab. Do you have any suggestions? Because as you know, the access to technology is very limited in the country. Number two, we're just trying to inculcate the knowledge of digital fabrication. Number three, we're just 750,000 people. So what would your recommendation be? Anyone, Julian, Daniela?
Well, we can both have some ideas. I think the Fab Festival that you organized, I think that was a very good idea and it attracted a lot of people that were just curious about what's going on. So organizing events like this, so we have a lot of, we have the luck that we are in the center of the city and a lot of people pass by. But you can also organize targeted events where you invite people and like show them what they can do here. And then maybe they get interested in actually come. I mean, if they start a project, usually they get to know people, they talk to people about what they're doing, and then they want to stay there. They learn how to use the machines, they will show other people how to use the machines, and maybe they will even start collaborations on their projects. So yes, invite people here. I don't know, at least in Europe, in the Christian world, we have Christmas, and this is where people always want to build their little presents. And then we organize workshops when we show people, look, with a laser cutter, you can build a very nice do-it-yourself present or tree decorations or something like that. This could be an idea. But what you already did, I think that there were lots of people we also talked to that were interested in your lab. So.
And then, yeah, I'm not sure how it's right now at the Fab Labs. Are there like opening days where anybody can just walk in? And were they advertised at the Fab Festival? So I think that's important to have like a structure where people know reliably they can go into that lab, and if they come back, it'll be still open to them, and they can use it. So I think having a structure and then maybe even already something like how do you, if you have a larger project, how can you follow up on that? How can you get access to the space for a longer period of time? That would help. And another idea that, or what we hope in the future will help us having school projects, but then also in the school projects, we would have all the children coming. Especially with the older children, that would mean that we have, like in the long term, we have the whole population eventually have gone through our lab. And then you there also offer how to follow up on projects. So not just the project you did in your class when visiting, but also what can you do afterwards when coming back. I think that's important to have them come back.
Thank you. Thank you for your answers. Anyway, please give a big round of applause for Danielle and Julian. I'll just check the time.
Yes.
It's 6:58. We'll start the prep for the movie. I don't know if Francisco is there. Oh, he's here. So please hold on. After this, we'll be screening an Oscar-nominated movie, which is called Lunana, A Yak in the Classroom, which was directed by Pao Choing Doji, using most of the local artists, local people, and people at Lunana as well. And this movie was nominated for Best Foreign Film Oscars last year. So I think it came second after Drive My Car, which is a Japanese movie. So please feel free, enjoy, relax. If you want any popcorns, it's towards the left side of me. There are 10 serving popcorns, food, drinks. If you want beer, please go at the cafe. There's a blue one and a red beer waiting for you. Red is 8%, blue one is 5%. If you mix it hangover, you'll have a bad hangover tomorrow. And tomorrow, we have a very interesting session as well. It's the economy track. We'll be having the CEO of DHI talk. We'll be having the former Prime Minister of Bhutan talk. So yeah, enjoy your night. Have a good time. Thank you, ladies and gentlemen. I'm Chirag, signing off.